What wonders hide in starlight? How does the sky guide you? What stories appear through the lens? You settle into a comfortable place as daylight slowly yields to evening. The air cools softly around you, carrying the scent of earth and the hush of twilight. Over the horizon, the last colours of sunset fade to deep blue, and a gentle darkness unfolds like a welcome cloak. In this quiet moment, you take a slow, deep breath, letting go of the day's thoughts. Night's first breath has arrived, calm and soothing, inviting you to look upward. Above, the sky transforms into a vast canvas of dusk. One by one, the first stars appear, timid glimmers at first, then growing bolder as the minutes pass. You notice a delicate pinprick of light low in the west, a planet, perhaps Venus, shining like a tiny beacon against the dimming sky. Higher overhead, another star twinkles into view, then another, until the heavens begin to sparkle softly. Each new light feels like a gentle greeting, a distant hello across the darkness. A sense of peace settles in with the darkness. The world around you is quiet now. The breeze has calmed to a whisper. If you listen, you might hear the faint rustle of leaves or the soft chirp of a night insect hidden in the grass. These subtle sounds only deepen the stillness. Under this growing tapestry of stars, you feel the weight of the day melting away. It is as if the night sky above is drawing you out of yourself, encouraging you to drift into its expanse. Slowly, your eyes adjust to the low light. Faint outlines of treetops or distant hills might frame the horizon, but your gaze is drawn higher, to where the sky is darkest. In that velvety darkness overhead, there are more stars now than you can easily count. They emerge gradually, a new one each time you sweep your eyes across the dome of night. Some shine brighter, others faint and shy, hiding at the edge of visibility. Together they form a gentle, silent chorus of lights. Across the dome of the sky, a faint silver mist is appearing now, a soft band of light brushing through the darkness. This gentle glow is the combined light of uncounted distant stars, so numerous and so far away that their individual sparks merge into a delicate river across the night. As you watch, you feel connected to something larger. The night doesn't feel empty at all. It feels full of stars, full of stories yet to unfold. There's a subtle anticipation in the air. It's as if the cosmos itself is aware of your presence and is patiently waiting for you to notice it in return. You sense that an old, long-forgotten dialogue is beginning anew between you and the universe overhead. The night's first breath has opened the door. Now the voyage can truly begin, guided by the light of countless stars above. Your eyes begin to trace patterns among the specks of light. At first, it's like connecting random dots on a vast canvas, but gradually familiar shapes emerge. High in the northern sky, a curved handle and a bowl of stars form a ladle-like figure. You recognize this as the Big Dipper, an old friend in the night. Its 7 bright stars glimmer patiently, just as they have for generations of stargazers before you. As you follow its outline, you recall that people long ago saw a great bear in these stars, stretching across the sky. Others imagined a wagon, a plough, or a dipper of water. Different names in different times, yet the stars remain the same, silently shining as stories swirl around them. All across the sky, these starry patterns act like gentle lanterns of memory. Each constellation carries with it tales whispered through the ages, legends of heroes, mythical creatures, gods and beasts that our ancestors saw in the stellar tapestry. Over there, low on the horizon, you might notice the graceful curve of Scorpius on a summer night, its tail curling with a faint sparkle, or the mighty figure of Orion rising on a winter's eve, belt stars aligned in a neat row guiding your eyes. If you listen to the silence, you can almost hear echoes of ancient storytellers pointing upward, spinning tales under the same canopy of stars. The constellations became their picture book in the sky, a way to remember important lessons and adventures, each twinkling light a part of a larger tale. Lying beneath this sky, you feel connected to those distant ancestors. You might imagine a small family centuries ago, gathered around a quiet fire under these stars, the night air cool and clear like tonight. A parent gestures upward, connecting the dots of a constellation as wide-eyed children listen in wonder. Perhaps they're hearing of a great hunter forever chasing his prey across the heavens, or a clever hero placed among the stars as a reward from the gods. The children gaze up, the firelight flickering on their faces, and for a moment, time dissolves. You and they share this one eternal sky. The tales may change with each culture and era, but the stars linking them remain constant. Tiny beacons tying together human lives across thousands of years. These patterns in the sky also quietly guide us. The ancients not only wove stories around them, but learned to use them as a map above. On clear nights, travelers would lift their eyes to find reassurance in the stars' positions. A particular arrangement of stars could tell them when the seasons were turning, or help them find their way across trackless oceans and deserts. Constellations rise and set with the flow of the year, marking the passage of time. The return of certain stars in twilight signaled planting time or harvest in ages past. In this way, the star patterns were more than mythology. They were a calendar and compass written in light. As you continue to gaze, you start noticing how one constellation leads your eyes to another. The sky is full of these gentle, connect-the-dots guides. From the curve of the Big Dipper's handle, your eyes follow it arcing across to another bright star, orange Arcturus, shimmering solitary in the spring night. And from the Dipper's bowl, two pointer stars on its edge, direct your gaze toward a certain star, hanging by itself in a darker patch of sky. This is Polaris, the North Star, steady and ever watchful in its spot. Unlike other stars, Polaris barely moves as the night passes, holding nearly still, as though pinned to the vault of heaven. For countless generations, it has been a beacon of the north, helping wanderers find their way. By following these lanterns of memory in the sky, you too begin to orient yourself. You feel a quiet confidence that even in the darkness, the stars provide guidance. And now, with Polaris glinting ahead, you sense that you've found the cosmic compass that will guide the next steps of your voyage. Polaris glimmers with a steady reassurance. With this star as your celestial anchor, you feel an almost instinctual sense of orientation. You know now which way is north, even if the land around you lies in darkness. There's comfort in that knowledge, a gentle certainty in the midst of night. Overhead, all the other stars slowly wheel around Polaris as the hours pass, tracing out great circles in the sky. But Polaris holds firm, the hub of the cosmic wheel. If you could watch the night sky in time-lapse, you would see the Big Dipper, Cassiopeia, and all their neighbouring stars pivoting gracefully around that fixed point. It is like a silent ballet that repeats every clear night, a dance ongoing long before you or anyone watched, and one that will continue long after. This nightly turning of the sky has long been both guide and calendar. As the Earth spins on its axis and journeys around the sun, the tapestry of stars shifts slightly night by night. The patterns you see overhead change with the seasons, offering a quiet rhythm to the year. On crisp winter evenings, the hunter Orion dominates the southern sky, his bright belt and shoulders shining through the chill. As months roll on, Orion slips toward the west, and the skies of spring bring the gentle sparkle of Leo and the delicate cluster of the Pleiades fading in twilight. Knowing this cycle of the heavens gives you a deeper sense of time's passage and your place within it. To lie under a summer sky and recall the winter stars that once glittered, there is to feel the slow turning of Earth beneath you. The heavens are a clock, but one that never rushes. Its hour hand moves with the seasons, and its face is the entire sky. By recognizing which constellation rises at dusk, or which stars linger before dawn, you come to know the time of year, just as surely as knowing the hour from a shadow's length. Our ancestors learned to read this great clock of stars with devoted attention. They knew when to plant and when to harvest, by which constellations appeared in the pre-dawn or twilight sky. For them, the sky was an almanac written in light, quietly telling the story of each passing month. Today we have modern calendars and bright city lights, but high above, the ancient rhythm of the stars continues unabated, steady and patient for those who remember to look up. With Polaris to guide north and the seasonal stars as your calendar, you feel grounded and at home beneath the sky. The idea of being lost in the dark fades away. Even in an unfamiliar land, a clear night can offer a map of familiar patterns. Perhaps you imagine being a traveller in olden days, finding your way by starlight when earthly landmarks were few. Out on the ocean, sailors steered their ships by Polaris, gauging its height above the horizon to estimate their latitude. Across deserts and wilderness, wanderers looked up for the North Star, or for the rise of certain stars, to reassure themselves of the path ahead. You share in that ageless tradition now, letting the night sky orient not just your steps, but your soul. There is quiet confidence and companionship in sensing the sky as your guide, a constant above the uncertainties of the world. As you bask in this calm sense of direction, a gentle curiosity awakens about those countless stars themselves. You have learned their patterns and motions, yet they remain distant and mysterious, each a tiny spark whose true nature is hidden by the great gulf of space. Your eyes can collect only a little of their light. To discover more, you would need a way to gather their faint glow and magnify it. Over the centuries, stargazers found just such a way. The telescope, a simple tube of glass and mirrors that can bring the far-off lights closer. Now imagine you reach for such a device, placing your eye to a lens that sips starlight. In doing so, you prepare to venture deeper, to see sights that your unaided eyes could never behold on their own. You carefully position the telescope and peer through its eyepiece. At first, you see nothing but darkness as your eye adjusts to the narrow, light-gathering view. Then, as you relax and focus, a tiny scene emerges. Stars. So many more stars than you could see with just your eyes alone. Where the night sky looked like a handful of lights before, the telescope reveals dozens more in that same small patch of sky. It is as if the telescope is a kind of gentle amplifier, taking the faintest whispers of starlight and making them just bright enough for your eye to catch. You find yourself gazing at a cluster of stars that was invisible a moment ago, now appearing as a sprinkling of fine diamond dust. Some of those stars seem to form patterns of their own within the eyepiece, little micro-constellations you've never known were there. Using the telescope requires patience. You steady your breathing, keeping still so as not to jostle the delicate tube. Every slight adjustment of focus brings new clarity. A faint point of light sharpens into a star, and a dim haze might resolve into a cluster of many stars. Sometimes you catch yourself holding your breath as you concentrate on teasing out details at the edge of visibility. The longer you look, the more your eye seems to notice. A faint glow that barely registered at first begins to show a hint of structure, a wisp of nebulous light, or a subtle change in colour among the stars. It's almost like the telescope is teaching you how to see more deeply, rewarding your stillness and attention with the gift of a clearer view. Above you, the night remains tranquil and vast. But through the telescope, you've entered a more intimate realm of the sky. You gently pan the telescope across the Milky Way, that hazy river of starlight you noticed earlier. Now, instead of a continuous glow, you see countless individual stars packed together. Here and there, clusters of stars stand out, tiny gatherings of siblings born together long ago. One such cluster comes into view, a tight knot of stars glittering like a handful of salt sprinkled on velvet. These stars have travelled the galaxy as one family for millions of years, and now you catch a fleeting glimpse of their fellowship from afar. The sight is subtle, not a bright spectacle, but a gentle scene that gradually impresses itself on your awareness. It feels like peering through a window in space, seeing a private little celebration of stars that was hidden to unaided eyes. As you continue exploring, you turn the telescope toward a faint, cloudy spot in the sky that you recall noticing with your naked eye. Through the lens, this foggy patch blossoms into a delicate cloud of light. In its heart, you think you catch the glimmer of a few stars being born, winking within swirls of cosmic mist. You're witnessing one of the galaxy's nurseries, the very beginnings of new stars nestled in their cradle of gas and dust. It is a humbling sight. This small telescope view holds light that has travelled across space for perhaps 1,000 years or more before meeting your eye. Patiently gathered by the telescope's lens, that ancient starlight now reveals something of its journey, a birthplace of stars glowing softly in the darkness. Using a telescope, you realise, is about more than just seeing farther. It's a practice in patience and wonder. Each time you find a new object or detail in the eyepiece, it feels like unlocking a tiny secret of the night. You remember that the first astronomers to use such instruments, centuries ago, must have felt this same thrill. Galileo, lifting a simple spyglass to the sky, suddenly saw moons orbiting Jupiter and mountains on our moon. The universe opened a little more to human eyes on those nights. And ever since, telescopes have been extending our senses, sip by sip, collecting the faint light that carries the stories of distant worlds. They have shown us galaxies like swirling islands, nebulae like gossamer clouds, and stars too numerous to count. With each careful observation, we learn to appreciate how vast and rich the cosmos truly is. Under the quiet sky, you step back from the telescope for a moment and gaze up once more directly. Your eyes, though less powerful than the lens, now seem to catch a bit more than they did before. Perhaps it's imagination, or perhaps your time at the eyepiece has simply attuned you better to the subtle lights above. You find yourself wondering about the nature of these faraway suns. The telescope has shown you clusters and clouds where new stars form, and countless points of light that fill the dark. How far away are they really? Some that looked like they were neighbours in the eyepiece might in truth be separated by unimaginable distances. To journey further, you realise, one must also measure the depth of space. And indeed, over time, stargazers learn to do just that, finding ways to gauge how far their cosmic neighbours truly are, one gentle step at a time. Back at the telescope, you notice something intriguing about one particular star. On a winter night, it sat close by a faint cluster in the eyepiece view. But when you look again half a year later, its position seems to have shifted ever so slightly. At first, you wonder if it's your imagination or the telescope's alignment playing tricks. But it's real. The star has moved just a hair's breadth against the backdrop of far more distant stars. This tiny celestial wiggle is called parallax, a gentle shift in perspective caused by Earth's journey around the Sun. By observing that shift, astronomers found a way to measure the vast gulf between us and the stars. The idea is simple, but profound. As Earth travels from one side of its orbit to the other, nearby stars appear to change their position slightly relative to farther stars, much like a nearby tree shifting against distant mountains as you walk. In practice, the effect is incredibly small. For even the closest stars, the angle of shift is minute, like the thickness of a coin seen from across a room. For a long time, this tiny motion eluded our instruments. It wasn't until the 19th century that astronomers, armed with precise telescopes, managed to detect the parallax of a star. When they did, it was a revelation. At last, a direct measurement of stellar distance. The nearest star, they found, was still unfathomably far away. With a bit of geometry, that hair-thin angle revealed the star's distance. They could finally put a number to the void between us. It turned out that even the closest stars are separated from us by trillions of kilometers. Astronomers needed a new unit to grasp such immense spans. The light year, the distance a beam of light travels in 1 year. Light moves fast, about 300,000 kilometers each second. Yet even at that tremendous speed, it takes years to journey from our nearest neighbours to Earth. The star with the first measured parallax was found to be over 10 light-years away. That means the faint glow entering the telescope's lens had been on its way for more than a decade before it finally touched the eye of the observer. Such is the scale of our cosmic neighbourhood. These gentle measurements were our first steps into the vast distances of space. Each successful parallax measurement felt like extending a hand across the darkness and finding a solid point to hold on to. One by one, the distances to nearby stars were charted, and an invisible map of our stellar neighbourhood began to take shape. We learned that our sun is not alone, but part of a small community of stars drifting together in a quiet corner of the galaxy. Knowing the distances helped us picture the arrangement. Which stars are truly close by, and which only seem near each other from our perspective on Earth. It was as if we had finally turned on a gentle nightlight in the dark room of space, illuminating where things stand around us. As you contemplate these enormous distances, a quiet awe washes over you. The stars you see on any given night are not just lights on a flat dome. They are far-flung suns, scattered in 3 dimensions, with unimaginable voids between them. Our closest neighbouring star is so distant that if you were to travel at the speed of the fastest spacecraft humans have ever built, it would still take you 1,000,000 years to get there, take tens of thousands of years to arrive. Yet in the grand scheme of the galaxy, those nearby stars are like a tight-knit little cluster around us. With the ability to measure distance, you can now truly sense the scale of this realm. It gives perspective. Our own sun and Earth are just one tiny island in a vast archipelago of stars. And now, knowing the way, it's time to visit our nearest cosmic neighbours in this great, dark ocean of space. Armed with the knowledge of distance, you set out to meet the sun's nearest stellar neighbours. Floating in the quiet darkness, you realise how vast the gaps are, even between the closest stars. Our sun's neighbourhood is sparse and peaceful, a small collection of stars glimmering far apart from one another. There is Alpha Centauri, the nearest star system, whose light takes just over 4 years to reach us. And there is Barnard's star, slightly farther, but quietly remarkable in its own way. Each neighbour has its own story, unfolding in the deep stillness around us. Alpha Centauri shines as a beacon among our neighbouring stars. If you were far south of the equator on Earth, you could point out this brilliant star system easily in the night sky, twin to the Southern Cross's pointer stars. Up close, you would find that Alpha Centauri is not a single star at all, but a pair of golden suns dancing around each other. Each of these two stars is similar to our sun, pouring out light and warmth. They are locked in a slow orbital embrace, circling a common centre as they have for billions of years. Accompanying them is a third, much smaller companion, a dim red dwarf star known as Proxima Centauri. Proxima is so faint and far from the main pair that it hides in their glare, unseen, without a telescope. Yet it holds the distinction of being the closest star to our solar system. Imagine standing on a hypothetical planet orbiting that little red star. Our sun would appear as just another bright star in its sky, a distant pinprick of light, 4 light years away. Barnard's star, in contrast, is a quiet and unassuming neighbour. It emits only a feeble red glow, far too faint to see without the aid of a telescope, even though it lies just 6 light years from us. This star is smaller and older than the Sun, a red dwarf that has been burning gently for nearly twice the age of our solar system. What makes Barnard's star stand out is not its brightness, but its motion. It is darting through space relative to the other stars at a notable pace. If you could watch the sky over centuries, you would see Barnard's star slowly shifting position against the background of more distant stars, inching its way across the constellations. It's like a solitary traveller quietly hurrying along, while others seem nearly motionless by comparison. This swift motion is a reminder that even in the stillness of the night sky, the stars are moving on their own journeys. Only their vast distances make them seem fixed in place to our eyes. Besides these, our neighbourhood hosts other stars as well. Some bright, like Sirius, the dog star, about 8.5 light years away, and dazzlingly luminous in our night sky. Others are dim and hidden, like red dwarfs that vastly outnumber the bright stars, yet rarely announce themselves. Most of our nearest neighbours are actually these faint red suns, quietly glowing with a fraction of the sun's light. They form a kind of gentle background presence around us, largely invisible without instruments, but forming the fabric of our local stellar community. In the grand picture, our sun and its handful of nearby stars drift together in a sparse suburb of the galaxy, bound by gravity yet separated by immense voids. All these stars, our sun included, move within a great cavity in space known as the local bubble. This bubble is an expanse of tenuous gas, stretching hundreds of light years across, where the usual interstellar clouds are absent. It's as if long ago, some powerful stellar winds or explosions cleared out a vast chamber in the galaxy's disk, leaving a region of relative clarity. Inside this bubble are local stars floating quiet, with few dense nebulae or dust clouds to disturb the view. On the bubble's distant walls, far beyond our little cluster of stars, lie the clouds where new stars are being born. But here, in the centre, it is calm. Our sun and its neighbours sail through this peaceful cosmic bay, enjoying a respite from the bustling star-forming regions outside. Imagining this, you feel a sense of gentle shelter. Our cosmic neighbourhood is like a tranquil lagoon within the vast ocean of the Milky Way. In time, of course, even this bubble will change, as our solar journey carries us to new regions, and as distant stars evolve and explode. But for now, we live in a quiet place between the stars, a place that we can call home before we venture further outward. Drifting farther from our sun's quiet neighbourhood, you begin to notice the sky itself changing subtly. The Milky Way, once a uniform, gentle band of light, reveals texture and pattern. Great dark rivers seem to cut through the stellar glow, like ink-black currents winding across a luminous sea of stars. One prominent dark lane stretches overhead on a summer night, splitting the Milky Way's bright stream into two. To the untrained eye, these voids might appear as empty stretches of sky where no stars exist. But you now know they are anything but empty. They are the silhouettes of immense interstellar clouds blocking the starlight beyond. These are the dark nebulae, cosmic rivers of dust and gas that drift through the galaxy. The dust grains within them are tiny, microscopic specks of carbon and other elements. Yet collectively, spread over trillions of kilometers, they form thick clouds that light struggles to penetrate. They are like soft, velvety curtains drawn across the stars. Behind them, countless stars continue to shine, but their light is scattered and absorbed by the dusty veil, leaving us with the impression of darkness. In reality, the darkness is a tapestry of its own, rich in material, the raw stuff from which new stars and planets may one day form. It's a gentle irony that some of the darkest patches of sky harbour the ingredients for creating future starlight. As you glide alongside one of these dark clouds, the experience is quietly sublime. Starlight from behind filters through in faint and ghostly hues at the cloud's wispy edges. Deeper toward its centre, the cloud is opaque, an inky silhouette against the glittering background. Your imagination wanders into that darkness, wondering what secrets lie in its lightless depths. Perhaps there are stars in there, newborn or unborn, cloaked in the dust until they burn bright enough to reveal themselves. For now, the cloud keeps its quiet mysteries. You feel almost as if you're walking through a dark forest at night, surrounded by towering shapes you can't quite see, but knowing they are full of life, unseen. Throughout history, people have gazed at these dark rifts and given them meaning, much as they did with the stars. In some cultures, the darkness itself became the outline of celestial creatures. An emu stretched across the sky in the eyes of ancient Australians, or a llama nestled in the Milky Way for the Inca. They saw that the night's canvas was painted not only with points of light, but also with the shapes of shadows. It is a reminder that absence can be as evocative as presence. The spaces between the stars can tell a story of their own. Each dark nebula is like a quiet pause in a song, or a resting note in the symphony of the galaxy, giving contrast and depth to the shining tones of starlight around it. As your journey takes you farther along our galaxy's spiral arm, you weave in and out of these dusky clouds. There are moments when a particularly thick dust river obscures whole swathes of sky, leaving only the nearer stars visible around you. In other moments, you emerge into a clearer patch where the full glory of the Milky Way returns. This alternating dance of dark and light guides you gently onward. And then, on the horizon of this cosmic ocean, you begin to notice a faint glow beyond the darkness. It's subtle at first, a delicate, diffuse light peeking around the edge of a soot-black cloud ahead. Unlike the pinpoint shine of stars, this light is hazy and softly coloured, like a distant lantern behind a curtain. A sense of anticipation grows, for you realise that beyond the dark nebulae lies something luminous, perhaps a place where the veil of dust thins and newborn stars set the surrounding gas aglow. The sight beckons you forward, promising that the calm shadows you've travelled through will soon give way to an illuminated realm, a stellar nursery shining just beyond the dark curtains. You follow the beckoning glow and soon find yourself entering a more bustling region of the galaxy. The darkness of the dust clouds begins to thin, and ahead the scenery transforms. Like dawn breaking after a long night, a vast luminous cloud unfolds before you, suspended among the stars. This is a stellar nursery, one of the bright nurseries that had shimmered on the horizon of your journey. It is here, in these colourful clouds, that new suns are being born. Drawing nearer, you recognise this region from stargazing nights on Earth. It is the Orion Nebula, nestled in the sword of the Orion constellation. What appeared as a faint misty star to the unaided eye now reveals itself as an enormous canvas of light and colour. Swirls of glowing gas spread out across dozens of light years, tinted in rose and violet hues. Streaks of dark dust wind through the nebula, but unlike the cold, opaque clouds you passed earlier, here the dust and gas are illuminated from within. The nebula's edges fade into the starry background, while its heart shines brightly, alive with energy. At the core of the Orion Nebula, a cluster of infant stars is coming to life. They huddle together in a brilliant group, their combined radiance carving away the cocoon of gas that once enveloped them. These young suns, only a few million years old, are hot and blue-white, and their fierce light causes the surrounding hydrogen gas to glow a soft, pinkish red. You can see tendrils of that glowing gas twisting outwards like gossamer clouds, pushed by stellar winds from the newborn stars. Every so often, a tiny flicker betrays a new star igniting, adding its light to the nebula's shine. This place is both tranquil and dynamic. Tranquil in its silent vastness, yet dynamic in the slow blossoming of new stars within. Entering fully into this spiral arm, you sense that such nurseries are scattered all around. The Orion Nebula is just one of many cosmic cradles along this stretch of the galaxy. Not far from here glows another cluster of youthful stars wreathed in nebulous light, and farther on, countless others, too faint or distant for us to see without aid. Our Orion arm, this local branch of the Milky Way, is dotted with stellar nurseries and clusters like towns along a country road, each one a hub of creation amidst the dark stretches between. As you drift through, you feel surrounded by the gentle fervour of star birth. It's a reassuring thought that even in the vast darkness of space, there are pockets of light where new beginnings are constantly unfolding. The scale of this cloud is breathtaking. From one end of the Orion Nebula to the other, light must travel years to cross it. If you could wander inside, you'd find cavernous hollows sculpted by starlight and pillars of denser gas that might one day collapse into yet more stars. Some of those stars will form in groups, giving rise to new clusters that drift away over eons. Others may shine alone. For now, they are all held in this gentle incubator, slowly growing in strength. It's as if the galaxy has places reserved for nurturing its young, a network of cosmic nurseries where the cycle of stellar life perpetually renews itself. And here you are, witnessing one of those birthplaces firsthand, a bright oasis amid the starry desert. After the quiet emptiness of the local bubble and the shadowy passages through dust, this region feels alive and hopeful. The vibrant nebulae and gleaming clusters are like celebrations in the darkness, proof that even the cold void harbours creativity and light. Carrying the warmth of that realization, you prepare to continue onward. Beyond these nurseries and the familiar bounds of our local spiral arm, the galaxy stretches out even further, filled with wonders yet to explore. But before venturing farther, you take a moment to bask in the soft radiance around you. It's a gentle reminder that from darkness, light is born. And in the great expanse of the cosmos, new stars will always rise, lighting the way for those who wander. Gliding through the Orion arm, you encounter sights that are neither star nor pure darkness, but something in between, softly shining apparitions that hang amid the stars like distant lanterns. Ahead, a cluster of bright blue stars comes into view, their light strong and youthful. Surrounding them is a gentle blue haze, a faint cloud of dust illuminated by their brilliance. This is a reflection nebula, a cosmic mirror catching the starlight and diffusing it into a gauzy glow. The dust itself doesn't emit light, but it scatters the light of those hot stars, tinting it blue and spreading it outward like a halo. The effect is subtle and beautiful, as if the stars wear a delicate veil. One famous cluster wrapped in such a veil is the Pleiades, the Seven Sisters. In your mind's eye, you see it now. 7 bright stars close together, wreathed in an ethereal blue mist. On a clear night on Earth, the Pleiades are a tiny dipper of stars sprinkled on the winter sky. But here, as you drift nearer in our journey, the pale nebula around them becomes evident. It's a remnant of the cloud from which those stars formed, now reflecting their light as a soft radiance. This reflected starlight is gentle, an ambient beacon that quietly announces the presence of young stars to anyone wandering the galactic darkness. Further along, you come across another glowing cloud, but this one shines with its own vivid colour. It has a rosy, golden hue against the black backdrop of space, marking it as an emission nebula. Unlike the reflection nebula's borrowed light, this cloud is aglow from within. Here, energetic young stars and perhaps a recent supernova's shock have excited the hydrogen gas, making the nebula itself fluoresce. You are essentially seeing a neon sign of the cosmos, gas that has been energized to emit light of its own. The surrounding region is bathed in a warm, reddish gold light, a beacon of a different kind, more direct and intense, yet still diffuse and gentle in its spread. Reflection and emission nebulae often go hand in hand. In the grand star-forming regions like Orion, you saw both. The pink emission glow of hydrogen and the blue-white reflection glints in the nearby dust. Each type of nebula adds its hue to the galactic palette. Reflection nebulae tend to appear blue because dust scatters blue light more efficiently, much as our daytime sky is blue from sunlight scattering. Emission nebulae glow red or gold because excited hydrogen emits a rich red light, sometimes mixed with other colors from different gases like oxygen. Together they create a cosmic artwork, bright clouds of sapphire and rose drifting among the stars. These glowing clouds serve as ambient beacons in the night of space. They are not as piercing as a star's light, but their extended, gentle glow can be seen across great distances, like campfires shimmering on a far hillside. For travelers like us, they offer a comforting sight, signposts of activity and life in what might otherwise seem like endless dark void. When you spot a blue-tinged nebula, you know young stars are nearby, their light kindly scattered for your eyes. When you see a golden-red cloud, you understand that something energetic is happening there, new stars heating their cradle, or old ones leaving a final gift of light. Each nebula whispers a story of stars recently born or soon to be born, of cosmic dust and gas gathering and glowing. They invite you to slow down and admire the quiet fireworks of creation, burning softly and steadily over eons. Now you find yourself at the threshold of an even grander vista, drifting beyond the familiar territory of our local arm. You gaze ahead toward the inner reaches of the galaxy. There, a great assembly of stars and nebulae awaits, a concentrated tapestry of light and dark. It is as though you have come upon the outskirts of a bustling celestial city, a place where star formation is in full flourish. The faint suggestions of glow that teased you from afar have grown into a broad luminosity, marking the presence of a colossal star-birth region. This could be called one of the galaxy's great nurseries, a vast complex of gas and dust where countless stars are being born in waves over millennia. You pause in this moment, marveling at the scale of what lies ahead. The experiences of your journey thus far have gently led you here. You've floated through the quiet of near-empty space, navigated by the steady light of the North Star, peered through a telescope into hidden star clusters, measured the gulf to neighboring suns, and slipped among veils of cosmic dust. You witnessed the cozy gatherings of nearby stars and the delicate glow of nebulae nurturing new suns. Each step has been like moving through the chapters of an ancient story, one that tells how the darkness of space is continually brightened by the birth of stars. Now, ahead of you, that story is reaching a profound chapter, a region where creation is rampant and the night is alive with the glow of innumerable young stars. This great star-forming region is not unlike the Orion Nebula you visited, but on a far larger scale. Immense clouds span across hundreds of light years, entwined with clusters of hot stars that make the surrounding gas shine. Here the arms of the galaxy converge and overlap, rich with the materials of creation. Bright nebulae, crimson, blue, and gold, pepper the vista, blending into a diffuse golden haze of starlight from millions of suns crowded together. Dark lanes of dust also thread through, still present even in this realm of abundance, adding contrast and mystery to the brilliance. It is a scene of sublime contrast, chaos and order, darkness and light intermingling on the grandest scale you've yet seen. At this threshold, you feel a quiet thrill. There is more beyond, so much more to explore and understand. Yet there is no rush. The cosmos unfolds in its own time, and you are a patient voyager. You allow yourself a moment of rest here at the edge of this great nursery, absorbing the radiant view. In the silence, you can almost sense the collective heartbeat of all those newborn stars, a gentle thrum that seems to reverberate through space. It's a comforting sound imagined in the stillness, reminding you that even in the vastness, you are not alone. You are in the company of countless stars that share the galaxy with you. Ahead lies the continuation of this journey, a voyage deeper into the galactic heart, where even greater wonders beckon. With calm anticipation, you prepare to drift forward once more, ready to leave the familiar behind and venture into the luminous unknown. The path will carry you into the very wellspring of stars, where the night glows as bright as dawn with creation's light. For now, you linger just a moment longer on the threshold of this stellar nursery, savouring the transition. When you do finally push off into that brilliance, you do so gently, your spirit as quiet and expectant as the cosmic dawn ahead. The voyage continues, and the stars await. In the silent cosmic night, we drift onward through a sea of stars. Ahead, a faint rosy glow emerges in the darkness, nestled within the constellation of Orion, the Hunter. This gentle luminescence draws us in, revealing itself as the Orion Nebula, a vast celestial garden blooming with newborn stars. The nebula hangs like a gauzy veil in Orion's sword, a tapestry of light and shadow swirled across the sky, quietly glowing some 1,500 light-years from Earth. We approach slowly, enveloped by its pale nebular glow, and feel the hush of creation in the airless void around us. This nebula's grandeur defies comprehension. Spanning dozens of trillions of miles, it forms a cavern in space that could engulf countless solar systems. From our perspective, the Orion Nebula spreads across an expanse wider than 100 moons, yet it lies so far that its light has been travelling since ancient times to reach us. In its depths, time and distance lose meaning. We drift through a celestial abyss, where every glowing cloud is larger than worlds, and each subtle detail stretches across trillions of miles. The scale is serene and humbling, a reminder of how spacious creation truly is in this cradle of stars. Deeper into this stellar nursery, the view becomes a landscape of cosmic mist and silhouette. We glide between towering pillars of gas and dust carved by starlight, their edges aglow where infant suns illuminate them from within. In the heart of the Orion Nebula, a cluster of young, massive stars called the trapezium shines brilliantly, painting nearby clouds in hues of lavender, rose, and pearl. Dark tendrils of dust twist and curl away from these lights, forming cocoons of shadow that cradle embryonic stars still gathering strength. Here, light and darkness weave together, each new star wrapped in a quiet dusk even as it begins to shine. Though the Orion Nebula's brightest stars command our view, countless others are tucked away in its folds. Many newborn suns remain swathed in thick dust, their light invisible to our eyes, but present as a warm promise in the gloom. If we could peer in infrared, we would see a whole swarm of infant stars dotting this cloud, like embers glowing beneath ashes. We sense them only indirectly, as faint tremors of heat and gravity amid the cold. Surrounded by darkness, these hidden stars patiently await their emergence, quietly adding to the nursery's subtle energy. Occasionally, the stillness is pierced by a narrow beam of motion, a newborn star releasing a stream of particles from its poles. These protostellar jets slice through the nebular haze like cosmic searchlights, energizing the gas in brilliant streaks. Where the jets plow into surrounding material, they create small, glowing shock fronts, gentle sparks in the nebula's vastness. Yet even these dramatic births unfold in slow motion, their changes visible only over centuries. The overall impression remains one of tranquility, ephemeral beams and ripples that come and go, mere whispers of activity in an otherwise calm expanse. All around us, the nebula softly glows and whispers of creation. Time here moves in eons, as gravity and gas perform a slow dance that assembles new suns. Each bright burst of starlight we see is a testament to a collapse that took tens of thousands of years. A cloud giving birth to a star. In this cosmic garden, countless seeds of light lie hidden in the dark, just beginning to warm and stir. Deep within one shadowy cradle, we sense the gentle heat of a forming star, the faint promise of radiance that will soon push back the darkness. Before the protostar was born, this pocket of the nebula lay cold and unremarkable. A distant ripple, perhaps the shockwave of an ancient supernova or the pressure from other bright stars, disturbed the delicate balance of the cloud. Slowly, the denser region began to draw itself inward under gravity's gentle insistence. At first, the collapse was imperceptible, spread over tens of thousands of years, but it continued inexorably. Gas and dust drifted ever closer, gathering into a tightening sphere that grew hotter and denser at its core with each passing millennium. Within a dense cocoon of gas and dust, we find ourselves surrounded by darkness and gentle warmth. Here, a fragment of the nebula has collapsed into a tight embrace under its own gravity. The airless silence is heavy but calm. As atom by atom, the cloud drifts inward, drawn to the center. Encased in this deep shadow, nothing yet shines. The birth is still concealed in night, governed only by the pull of gravity and the stirring of heat. At first there is no visible light, only the growing warmth of compression and a faint infrared glow hidden in the dust. Deep inside, the nascent protostar is slowly gathering mass, its core pressure rising. In this sheltered womb of cosmic material, a new star is taking shape unhurriedly, heating gradually like a coal that smoulders before the flame. It has not yet ignited, but every moment brings it closer to the threshold where darkness will turn to light. Eons pass in patient silence until at last the tipping point is reached. Deep at its core, the pressure and temperature climb high enough for a profound change. Hydrogen atoms begin to fuse into helium, and a newborn star's fire is lit. A soft radiance blooms, first from the center, then spreading through the cocoon, turning the dark cradle into a warm, amber haze. The gentle glow grows steadily, pushing away the surrounding fog of gas. What was once only a promise of light becomes a small sun, its surface now shining with a calm new energy. In the quiet of space, this infant star takes its first breath of starlight and joins the cosmic dawn. In the aftermath of the star's awakening, not all of the surrounding matter is blown away. A broad, shadowy disk of gas and dust remains in orbit around the young sun, stretching out across billions of miles. We drift out into this plane and find ourselves among countless tiny particles, suspended in a slow cosmic whirl. Closer to the star, the disk glows faintly with reflected light and the warmth of the infant sun. Farther out, it fades into a twilight of dust, where sunlight is weaker and the chill of space deepens. Amid this primordial disk, dust grains swirl and occasionally embrace. When two motes of dust drift together, they often stick in their quiet collision. Over time, these tiny grains gather into larger specks, then pebbles, building up ever so slowly. Thousands of gentle contacts lead pebbles to become rocks, and rocks to become boulders, tumbling through the haze. As the ages pass, some of these clumps grow massive enough to tug at their neighbours, pulling in more material. In this way, seedling planets form, hidden in the dusty lanes, each a fledgling world assembling grain by grain. Gradually, the disk begins to take on structure as new worlds emerge. Broad rings and gaps appear, sculpted by planets coalescing and sweeping up the material in their path. In one of these cleared lanes, we glimpse a nascent planet, a swelling sphere of gas and rock that still glows dimly from its birth. It circles the young star in a stately orbit, accompanied by other infant planets taking shape in their own orbits. With each passing millennium, the disk grows thinner and more transparent as more dust finds its way into these newborn worlds. Within the disk, different regions promise different kinds of worlds. Closer to the young sun, the warmth allows only metal and rock to condense, foreshadowing the birth of small, dense planets with solid surfaces. Farther out, beyond a frost line, colder temperatures let ices and gases collect in abundance, seeding the formation of giant planets cloaked in clouds. Between these zones, myriad pebbles and snowflakes mingle, destined to become asteroids, moons, or comets. In time, this single disk will give rise to a rich menagerie of worlds, inner planets basking in their star's glow, and outer giants roaming through colder twilight, all bound in one family orbiting their parent sun. If we focus on one growing planet, we can imagine its own small disk of debris spinning around it, a cradle for future moons. Material pulled in by the planet's gravity forms rings around the nascent world, echoing the larger protoplanetary disk. Within those rings, tiny moonlets may be coalescing in the same gradual way, creating a miniature solar system in orbit around the new planet. The young planet itself is still hot and soft, perhaps glowing faintly from ongoing collisions. In the hush of space, it gathers mass bit by bit, while around it, new moons take shape, destined to accompany the planet on its journey around their star. At last, what remains is a delicate newborn solar system, a bright star encircled by the quiet company of its first planets. The major construction is complete. The central sun now shines steadily, and a family of worlds circles in the clean space that was once filled with dust. A few rings of leftover debris still linger, the seeds of future asteroids and comets, but the chaotic beginnings have calmed. In the stillness, a new stellar household has formed, ready to evolve over billions of years to come. Watching a star and its planets emerge from dust evokes a profound awe. In the span of cosmic time, a whisper of gravity can organize chaos into order, lighting a new beacon in the darkness. Every star in the night sky once kindled in this way, each with potential worlds forming quietly around it. Our own sun and earth were born from such a cloud eons ago, part of this unbroken cosmic cycle. To witness these first moments, the gentle fall of dust becoming a star and worlds, is to glimpse creation in its most peaceful form. Stars are born not in isolation, but in communities. The star we followed is just one member of a broader family that emerged from the same nebula. We now drift away from the single newborn system and find ourselves amid a glittering assembly of such stars, all siblings of one cosmic nursery. This is a young star cluster, a loose, radiant gathering of suns that have just begun their journey through space together. They shine like a swarm of fireflies in the darkness, each star's light adding to the gentle collective glow. Among these clusters, one of the most enchanting is known as the Pleiades, or the Seven Sisters. We drift into this cosmic family and find bright, blue-white stars scattered like a handful of diamonds on velvet. These stars are very young, mere tens of millions of years old, and they burn hot and vividly, illuminating wisps of leftover dust with a silvery blue sheen. The cluster's stars huddle relatively close, bound by their shared origin, creating a delicate patch of sparkle in the vast night. In the silence of space, the Pleiades exude a gentle, youthful energy, a sisterhood of suns shining together at the dawn of their lives. Not far from the Pleiades in the sky lies another stellar kindred, the Hyades cluster. We travel to this group and notice a subtly different scene. The stars of the Hyades are spread wider apart and shine with a steadier, more mature light. This cluster is older, several 100 million years along, and its youthful brilliance has softened. Among these stars, a few glow with a gentle amber hue, aged giants that have swollen and cooled with time. The Hyades still drift together through space, a looser family now, their bond held more by shared memory than gravity. In their collective glow, we sense a calmer warmth, the comfortable harmony of a star cluster that has passed the first flush of youth. At roughly 150 light-years away, the Hyades is one of the nearest star clusters to our Sun. Wandering through the Pleiades, we realize the Seven Sisters are merely the brightest of a much larger family. All around, fainter stars sprinkle the cluster, hundreds of siblings united by a common origin. Some are tiny red stars, barely glowing embers that tag along with their radiant sisters. Others may be double stars locked in gentle orbits around each other. In time, as the cluster orbits the galaxy, these stars will gradually drift apart, scattering the family into separate journeys. But for now, they remain together in a glittering congregation, a youthful gathering that will grace the galaxy for many ages to come. If one could stand on a planet within a young cluster like this, the night sky would be breathtakingly rich. Dozens of brilliant stars would burn in the heavens, far brighter than any in our own familiar sky. The nearest sister suns would cast pale blue glows onto the landscape, perhaps even creating a perpetual twilight with their collective light. Living in such a cluster would mean never knowing a truly dark night, as the sky is alive with the radiance of stellar kin. It is a cosmic neighborhood crowded with light, a reminder of the cluster's tightly knit beginnings. In these youthful clusters, we see stars not as solitary lights, but as part of a family. It is a reminder that even our own sun likely began life alongside siblings, long since dispersed into the galaxy. The sight of so many related stars together is comforting, a cosmic community bound by common birth. As the cluster drifts through space, it will gradually lose members to the vastness, but the kinship they shared in youth leaves an indelible imprint in their motions and compositions. Under the cluster's collective glow, one can sense the quiet bond linking these stars, a gentle fraternity that time will stretch but never entirely erase. These star clusters once emerged from swaddling clouds of gas and dust, and the memory of those clouds lingers in the space around them. To witness how young stars interact with their birth clouds, we turn our gaze back to the nebulas themselves. In those stellar nurseries, the radiation and winds from newborn suns stir the surrounding gas into motion. What was once a uniform haze becomes sculpted by light into wondrous shapes, pillars, arcs, and ripples floating in the starlit gloom. The gentle weather of starlight slowly carves the cosmic cloudscape, leaving behind ethereal structures that mark the passage of newborn energy through the dark. In a nearby stellar nursery, we find a breathtaking scene shaped by this celestial weather. Towering columns of gas reach out like ghostly hands, remnants of denser cloud left standing as surrounding material has been blown away. At the tips of these pillars, new stars hide, sheltered from the glare behind curtains of dust. Brilliant young suns nearby pour out intense light and swift winds of charged particles, which eat into the columns, sculpting their tops into delicate fingers and wisps. These formations drift ever so slightly as eons pass, slowly evaporating under the gentle onslaught of starlight. Beyond the pillars and bubbles, the nebula is draped in gauzy filaments and delicate veils. Starlight filters through these uneven wisps of gas, illuminating them like backlit clouds at dusk. Here and there, denser knots resist erosion a bit longer, casting tiny shadows and creating bright-rimmed edges that shimmer softly. The interplay of light and shadow forms a living mural that slowly changes over millennia. It is a scene of quiet weather in the heavens, not of wind and rain, but of photon breezes and chemical fog, shaping and dissolving cosmic clouds in silence. Elsewhere, the breath of a star takes on the form of a vast bubble. A mighty stellar wind flows outward from a hot, young star, pushing a spherical wave through the nebula. We see the outline of this bubble as a faintly glowing arc, like a soap bubble catching starlight on its surface. Inside its expanding shell, the space has been cleared, swept free of dust by the star's persistent breeze. Such bubbles and arcs drift quietly through the nebula, marks of how a single star's light and wind can shape the space around it into graceful forms. These delicate cosmic sculptures are fleeting works of art in the galaxy. Though they span light years, pillars and filaments will eventually disperse, erased by the same light that created them. For now, they stand as tranquil monuments to the influence of starlight, proof that even in the vacuum of space, there is a form of weather and change. To watch a nebula's slow dance is to witness creation and erosion in perfect balance, a gentle ebb and flow of matter, driven only by light and wind. It is a peaceful erosion, a slow shaping that leaves behind beauty in the wake of energy. Leaving behind the glowing nebulas, we seek out a solitary star with a secret heartbeat. In the darkness ahead, a star beckons with a gentle flicker, brightening slowly, then dimming again in a graceful loop. We draw near this pulsating sun and find that it swells and contracts in a steady rhythm. Its outer layers heat up and cool down in turn, causing its light to wax and wane as regularly as a breath. In the stillness of space, this star's slow pulse is like a soft cosmic heartbeat, a reassuring blink that keeps celestial time. The cycle of this particular variable star spans many days from one pulse to the next. Some stars complete their brightening and dimming in a matter of hours, while others take months to go through one slow heartbeat. Yet each remains steady in its cadence, repeating with a faithful regularity. If we charted the light over time, it would trace a gentle wave, a light curve as regular as the ticking of a clock. In the expanse of space, these pulsations are subtle beacons, steadily pulsing out a message that can be felt across thousands of light years. This quiet blinking carries meaning amid the emptiness. In these subtle cycles, the star is whispering its own power and distance. A remarkable cosmic secret hides here. The longer a star's pulsation period, the more luminous it truly is. By watching the tempo of the flicker and measuring the star's faintness from afar, one can divine how far the light has travelled. Thus, these variable stars serve as soft metronomes in the sky, gentle, reliable beat markers that help chart the immense gulf between the stars. Their rhythmic shining has guided explorers of the cosmos, acting as cosmic mileposts stretching out into the darkness. The gentle ticking of variable stars connects the cosmos like a great clockwork. Across unimaginable distances, these stars wink in agreement, giving us a way to measure and make sense of the void between galaxies. There is comfort in their predictability, a sense that even the vast darkness has a pattern and rhythm. Each pulsation is a reassurance that the language of nature is universal. A distant star's heartbeat can guide and orient us, bridging the gulf with its steady signal. In the quiet, we feel a companionship with these pulsing stars, as if they are keeping time with the universe itself, marking out the corridors of space with their light. As we gaze at these stellar rhythms, we discover some variations have a different cause entirely. Far off in the distance, a tranquil star momentarily dips in brightness, then returns to normal, repeating this pattern at fixed intervals. We draw closer and realize the star itself stays constant. The flicker is caused by a small companion slipping across its face. A planet, invisible in the blinding glare, is transiting its sun, casting a faint shadow that dims the starlight ever so slightly. Each time the planet completes an orbit, the star blinks softly in acknowledgement, a tiny eclipse marking the presence of a far-off world. Not all planets announce themselves with shadows. Some reveal their presence through gentle tugs on their parent stars. We notice another distant sun that seems to sway ever so slightly, a tiny wobble in its motion, as if dancing with an unseen partner. This star's subtle dance is caused by the gravity of an orbiting planet, pulling first one way, then the other. Though the motion is slight, it leaves an imprint. The star's light shifts in a telltale pattern, a rhythmic change like a quiet musical note. In this way, transits and wobbles become planet songs, the faint melodies by which distant worlds make themselves known in the darkness. There are even worlds that dance with double suns. In some distant systems, two stars orbit each other closely, while planets circle around them both, feeling the tug and light of twin suns. A planet in such a system would see two dawns and two dusks, its sky painted by dual stars rising and setting. The transit of such a world makes its starlight flicker in more complex patterns, a duet rather than a solo in the music of the night. Yet even these intricate signals are subtle and hushed, requiring patience and keen observation to uncover their celestial story. Each faint planet song invites us to imagine the world that sings it. Perhaps one such dimming reveals a giant world ringed with clouds and moons, a miniature version of our own Jupiter. Another subtle wobble might hint at an Earth-like planet, with water and continents beneath an alien sky. Across the light years, we cannot see these landscapes, but we can picture them in our minds. Sunsets on unknown horizons, clouds swirling above strange oceans. In the darkness between stars, these distant planets circle quietly, their presence betrayed only by the gentle music of gravity and light, waiting for the day we truly behold them. The knowledge of these hidden worlds brings a gentle hope. Astronomers listening from Earth have already discovered thousands of such exoplanets by these faint signals, proving that planets abound among the stars. Where once we saw only emptiness between suns, we now realize space is filled with far-off worlds, perhaps even life. Each star's subtle song of shadows and wobbles hints that we are not alone in having a home in the cosmos. It is a comforting thought in the great darkness. Beyond every beam of starlight could lie a place with its own skies and landscapes. As we drift onward, the sheer abundance of possible worlds makes the universe feel ever more alive and welcoming, even in its profound silence. Our journey now leads us to a twilight scenario in a distant corner of the galaxy. Here, a star much like our Sun has reached the end of its long life and is undergoing a gentle transformation. In its old age, the star has swelled into a red giant, its outer layers bloated and tenuous. Now, in a final act of grace, the star begins to shed those layers into space, exhaling its own substance into the surrounding darkness. Shells of gas drift outward, each one cast off in a slow, rhythmic pulsing over millennia. This dying star's atmosphere is peeling away, layer by layer, leaving behind a luminous farewell in the void. We float amidst the result of this stellar shedding, a planetary nebula, a delicate cloud of the star's own ash and aura. Around the fading star, layers of cast-off gas form an expanding sphere of ethereal colour. In places it appears as a glowing ring, in others as wispy, translucent shells overlapping like watercolour on black canvas. Hues of soft green and red mingle, emitted by different elements once forged in the star's core, now freed to space. At the centre, the star's core still shines intensely, its white light causing the drifting gas to fluoresce gently. The overall sight is serene and bittersweet, a star's final breath made visible, an elegant nebula that will linger for thousands of years before fading into the cosmic night. This final exhalation is not an end, but a new beginning in disguise. The gas drifting away will eventually enrich the galactic clouds with heavy elements forged in the star's life. When these clouds condense anew in ages hence, the cast-off matter of this star will help form future suns and planets. In this way, the star's legacy continues. Its ashes become the seeds of new worlds, scattered back into the cosmic soil. The cycle of stellar life turns gently onward, birth, growth, and graceful passing, each generation lending material to the next under the timeless night. To witness a star's farewell is to realize that endings in the cosmos can be gentle and full of grace. After a long life of shining, the star does not explode in fury, but sighs out its substance, creating a final halo of beauty. There is a profound serenity in this cosmic autumn, a sense that even as a chapter closes, the light lives on in a different form. The colours and patterns of the planetary nebula are like a soft requiem, a tribute to the star's lifetime of contributions. In time, the nebula will fade, but its existence comforts us with the knowledge that even death can beget splendour and pave the way for new life in the universe. At the heart of the fading nebula, the source of its illumination remains. A white dwarf, the exposed core of the old star. This tiny stellar ember is no larger than a planet, yet it contains nearly the mass of the Sun compressed inside. It glows a brilliant white blue, exceedingly hot from a lifetime of nuclear burning that has now ceased. No longer fueled by fusion, it shines only with stored heat, radiating away its energy into space. Up close, it would outshine any diamond, a point of fierce light in the darkness. But its brilliance is the silent leftover of a fire that has gone out at the source. Time slips by without measure, and slowly this brilliant ember begins to cool. What was once a white-hot beacon will, over billions of years, fade from white to blue, from blue to gold, and from gold to deep red. The white dwarf shrinks in brightness, turning into a dim ruby pinpoint, and then a mere warm glow, like a coal fading to ash. In the unimaginable future, it will cease to shine at all, becoming a cold, dark remnant. For now, it remains a quiet whisper of its former self, a subtle warmth persisting in the night, a memory of a star that once was. This solitary white dwarf is one of countless others sprinkled throughout the galaxy. In every direction, far beyond our sight, ancient stars have ended their lives and left these faint embers drifting through the Milky Way. Like silent sentinels, they carry the memory of the stars they once were, each one a compact monument to a stellar lifetime. Some travel alone in the darkness. Others remain paired with companion stars, circling in quiet binary dances. Together, these white dwarfs form a vast, unseen population of cooling stars, slowly dimming as the eons roll on. The quiet endurance of white dwarfs is a testament to the longevity of starlight. Long after a star's active life is over, its core remains, cooling, but never quite forgetting the brilliance it once had. Someday, countless ages from now, our own sun will join this legion of pale star ghosts, quietly glowing to itself as the universe continues around it. To drift among these stellar embers is to sense history, frozen in time. Each one a story of a star that lived, shone, and gently faded. They teach us that even in silence and solitude, there is dignity and light, persisting against the backdrop of eternity. Drifting away from the quiet ember of the white dwarf, we pull back to rejoin the grander vista of our galaxy. Around us stretches one of the Milky Way's vast spiral arms, a curving river of stars, nebulae, and cosmic dust. We align our path with this stellar highway, letting its gentle bend guide our journey. As we turn along the arm, thousands of suns sparkle by, some in clusters, others solitary, all embedded in the gauzy glow of distant starlight. The dark ribbons of interstellar dust weave through the starry band, like misty lanes marking our route deeper into the galaxy. As our journey carries us onward, the soft glow of the galactic core begins to rise ahead. Far away, towards the center of the Milky Way, innumerable stars gather in a dense swath of light. It appears as a faintly golden haze against the darkness, the combined radiance of millions of suns overlapping. Though still distant, this central hub of our galaxy beckons with its mysterious brightness. One day, our voyage may take us there, but for now, we follow the spiral's curve, content to drift along this starry avenue into deeper cosmic realms. As we glide along the galactic arm, we become aware of our place in a vast pinwheel of stars. Each spiral lane is a bridge between past and future, lined with the lights of billions of suns. From within, we can appreciate the gentle curvature that guides our journey, an invisible road marked by star clusters and nebulae. There is a comforting rhythm to the galaxy's rotation. It carries us forward, assuring us that the voyage will continue. Somewhere ahead, more wonders await discovery. Our path through the Milky Way is only just unfolding, an endless expedition under the eternal night sky. With each light year we traverse, the vista slowly changes, yet remains endlessly rich with wonders. Our journey is far from over. Ahead, the spiral arm winds toward the galactic heart and outward again, promising new mysteries around every curve. The stars around us turn ever so gently, carrying us with them in a grand galactic rotation. In this serene odyssey, we remain suspended in the starlit vastness, bound for the unknown reaches of the cosmos. And so we glide onward, deeper into the spiral lanes, where the eternal night sky continues to unfold its quiet secrets before us. In the wake of turbulent stellar births, the cosmos finds a gentle equilibrium. We drift onward through a realm of mature stars, leaving behind the chaos of creation. Here, countless suns glow in quiet harmony, each a steady beacon in the darkness. Their light is no longer the fierce blaze of youth, but a warm and constant radiance that fills the interstellar night with reassurance. These stars are the houses of fire in our galaxy's vast neighborhoods. Deep in each star's heart, a continuous fusion of hydrogen unfolds like a cosmic hearth, burning quietly and steadily. Outward pressure from that inner fire balances perfectly against gravity's inward pull, creating a long-lasting peace within each stellar core. It is a delicate and enduring harmony, allowing the star to shine uniformly for eons without wavering in its luminance. The lifetimes of these main sequence stars are measured in ages beyond comprehension. A star like our Sun will pour out its golden light for billions upon billions of years, its flame hardly flickering over the millennia. Smaller stars, the dim red dwarfs, burn even more slowly and can live for trillions of years, outlasting most of their brighter cousins. In contrast, a few giants among them blaze hotter and larger, racing through their lives in mere millions of years, brilliant but brief candles against eternity. We glide past stars of many colours, noticing the soft differences in their glow. Some shine with a cool reddish comfort, while others gleam white or blue-white with a sharper intensity. Each hue is a clue to the star's warmth and size, yet all share the calm stability of this long middle chapter of stellar life. They are steady lanterns hanging in the void, guiding our path with their collective gentle illumination. Some of these steady stars are not alone, but come in pairs or groups. Two main sequence stars may orbit each other in a graceful celestial dance, bound by mutual gravity. We spot one such binary ahead, a golden sun twinned with an orange companion circling a common center. They share their light and heat across space, each star rising and setting in the other's sky in an endless exchange. Such double stars are a reminder that even in the vast loneliness of space, companionship can be found. In this tranquil passage of our journey, one can sense the nurturing embrace of these steady suns. Around some of them swirl planets and moons, quietly basking in their stars' reliable light. On those distant worlds, if life exists, it can flourish under the constant day provided by a faithful star that neither dims nor falters. This is the gift of the main sequence, a prolonged steadiness, a cosmic afternoon that stretches on for epochs, fostering stability in the surrounding space. Among these countless steady stars is one very familiar to us, our own Sun. It is a moderate star in midlife, quietly fusing hydrogen into helium, just as its peers do across the galaxy. By cosmic standards, our Sun is unremarkable in size and brightness. Yet to us, it is everything. A warm constant that has nurtured life on Earth for ages. The Sun's dependable glow is a perfect example of main sequence tranquility, a golden beacon that faithfully rises and sets without fail in our sky. Most of the stars peppering the night sky belong to this long, stable chapter of existence. They do not erupt or fade suddenly, but instead change only subtly over spans far longer than human history. Gazing at them from Earth, generation after generation sees nearly the same constellations, the stars' brightness unwavering over millennia. Yet even these peaceful houses of fire will not last forever. One day, each star's deep reserves of fuel will ebb. When that happens, the star will begin to change, relinquishing its steady youth and stepping into a more uncertain stage of life. Leaving behind the realm of steady midlife stars, we venture deeper and encounter stellar giants that have outgrown their youthful stability. Before us looms a star swollen to an astonishing scale, a red supergiant glowing with a dusky, ember-like light. It is as if a tiny sun has been magnified hundreds of times over, its outer layers expanded and cooled to a ruddy hue. This star's presence is gentle yet immense, a vast elder of the galaxy, standing in quiet contrast to the smaller stars around it. The red supergiant's atmosphere is so extended and diffuse that it blurs into the surrounding space. If this behemoth replaced our Sun, its bloated surface might reach beyond the orbit of Mars, engulfing the space where several planets now circle. Yet despite its enormous size, the star's light is soft and mellow, a crimson glow that pulses subtly over long periods. We watch as it sighs out shells of gas and dust in slow breaths, forming a delicate mist around its enormous form. Drifting onward, we find another giant, very different in colour and temperament. A brilliant blue-white supergiant shines ahead, smaller in girth than its red sibling, but far hotter and more luminous. This star radiates an intense, piercing light, its energy pouring out in great floods that outshine thousands of lesser suns. Where the red giant was cool and gentle, this blue supergiant is fierce in brightness, casting crisp shadows even across the emptiness of space. Despite their differences, both red and blue supergiants share a similar story. Each is a star in its twilight, having left behind the stable years of youth. Deep within their cores, the simple fuel of hydrogen is nearly gone, and heavier elements now burn in layered shells. This churning interior makes the giants swell and shine with extraordinary power, even as it signals that their days of shining are numbered. They have entered a grand yet precarious old age, one that they will not escape unchanged. We sense an uncanny patience in these titanic stars. Their changes, though inevitable, occur on timescales hard to grasp. A slow contraction here, a gentle brightening there, each step unfolding over years or centuries. To our brief human perspective, They seem almost eternal, maintaining their stately radiance night after night. Ancient peoples on Earth looked up to some of these giants, like the ruby star Betelgeuse or the brilliant Rigel, and saw constant guideposts in the sky, unaware of the slow transformations underway deep inside. Hovering near a supergiant, one can feel the tenuous winds flowing from its surface, carrying bits of the star away into space. These massive stars continuously shed material, creating halos of faint nebulae around them, a gentle prelude to far more dramatic events to come. It is a peaceful shedding, as if the star is slowly casting off memories of its long life into the cosmos. Drifting through this diffuse halo, we sense how even in dying, a star can be graceful, each lost fragment glimmering softly before fading into the dark. Yet beneath the calm exterior of these stellar giants, great forces are at work. Gravity presses inward with tremendous weight, and the core grows hotter and denser with every passing moment. In time, these forces will reach a critical threshold. One day, perhaps without warning, the quiet giant will suddenly unleash all its pent-up energy in one final, spectacular act. It will light up the galaxy for a brief moment, before the star's light ultimately fades. Among the millions of stars we have passed, these supergiants stand out as rare beacons. Only the most massive stars swell into such titans, and they are few and far between in any given starfield. In our long voyage, for every solitary red or blue giant we encounter, countless smaller stars twinkle anonymously in the distance. This scarcity makes each giant feel special, a precious lantern set in the cosmic tapestry, commanding attention by sheer presence. Interestingly, these giants have not travelled far from where they first ignited. Their existence is fleeting by cosmic standards. These stars remain near their birthplaces, cosmic children that grew up and aged in the same celestial neighbourhood. The red supergiant we admire may still lie near the stellar cluster that was its cradle, its slow orbit hardly carrying it away before its life will end. The journey around the galaxy is a short stroll for a supergiant compared to the grand circuits made by smaller, long-lived suns. Even now, the immense energy of a supergiant star profoundly affects its surroundings. The powerful starlight and stellar winds push nearby gas and dust outward, carving vast cavities in the interstellar medium. In some cases, the material shed by the giant forms bright nebular clouds nearby, illuminated by the star's own light. Thus, each giant shapes the space around it, creating cosmic landscapes that mark its presence, like a great tree casting shade and shedding leaves in a quiet glade of the galaxy. In a silent corner of the galaxy, a long, quiet star reaches its final moment. Without warning, its gentle light swells into a ferocious brilliance. A point of starlight that had been constant for millennia suddenly intensifies, outshining all others around it. For an instant in cosmic time, night turns to day in its vicinity as the star begins to tear itself apart in a cataclysmic flash. This is a supernova, the spectacular death of a star unfolding like a cosmic flower. From our distant vantage, it appears as a blossoming of light, a sudden celestial bloom against the dark canvas. The star's outer layers are cast off into space in a brilliant expanding shell, petals of gas and dust fanning outward at unimaginable speeds. Colours flare in the explosion's aftermath, fierce blue-white at first, then softening to hues of gold and crimson as the ejected material cools and spreads out. The energy released is staggering. Yet here in the vacuum of space, it arrives without a sound. Only an eerie, expanding glow marks the event. For days and weeks, The supernova remains a beacon, its brightness visible across vast distances. Astronomers on far-off worlds might notice a new star where none was before, shining intensely until gradually fading. Like a flower that blooms at night and withers by dawn, the supernova's transient glory slowly diminishes, leaving behind only ghostly traces. Such events are exceedingly rare in the life of a galaxy. Perhaps only a few times in a century does a star explode with such magnitude in a galaxy of hundreds of billions of stars. To witness one is a profoundly special moment. Ancient sky watchers on Earth recorded the sudden appearance of these guest stars with awe and fear. In modern times, we understand their nature, yet the wonder remains the same. A supernova is a fleeting cosmic firework, both beautiful and immense in its power. As the supernova's light fades, it leaves behind a vast expanding nebula, the delicate remains of the star strewn across space. These glowing remnants carry all the elements forged in the star's life and death, scattering them like seeds on the galactic wind. The surrounding interstellar clouds are briefly illuminated, as if nourished by the stellar blossom's last gift. Shockwaves ripple through nearby space, stirring gas and dust, perhaps even triggering the birth of new stars in time, life emerging from death. At the heart of the explosion's aftermath lies a dense secret. Where once the star's core shone, now a tiny, incredibly dense object remains, the collapsed heart of the star. This stellar corpse might be a neutron star, a city-sized sphere of degenerate matter left spinning furiously in the center of the expanding debris. Or if the star was truly colossal, even that core may have vanished into a black hole, an invisible gravity trap marking the spot where the star's center used to be. For now, as we drift among the fading embers of the supernova, all is calm again. The brilliant bloom has come and gone, and the galaxy returns to its gentle background glow. But the memory of that cosmic blossom lingers in the starlight around us. In time, the debris will expand and cool into filaments and clouds, and a new chapter will begin for the scattered remains. Yet even now, something new is quietly taking shape in the wake of the explosion. A rhythmic beacon born from the stellar ashes, ready to signal its presence in the darkness. Beneath the fading glow of the supernova's remnants, we detect a new, subtle flicker. It is here that the heartbeat of the dead star makes itself known. A pulse of energy washes over us at regular intervals, like a distant beacon flashing in the night. We have found the tiny stellar core we spoke of, now a pulsar, spinning rapidly and shining its light in rhythmic bursts. A pulsar is a cosmic lighthouse. As this neutron star whirls hundreds of times each second, beams of radiation sweep across space from its magnetic poles. Each time a beam crosses our line of sight, we perceive a pulse, an on-off pattern as steady as a ticking clock. In the great void, these pulses are like a gentle cosmic heartbeat, a reassurance that something endures even after the star's explosive death. Drawing nearer, we marvel at how such a small object can produce such precise signals. The pulsar before us is only a few tens of kilometers across, a sphere not much larger than a city, yet it contains more mass than our sun. Crushed into this tiny form, the star's matter has become exotic and ultra-dense, and its spin is incredibly fast and stable. It turns with absolute regularity, and has likely done so since the moment it was born from the supernova, rarely slowing down across the ages. The space around the pulsar is bathed in faint light and whispery radio waves. We cannot hear radio directly with our ears, but if we convert those signals to sound, we might detect a steady tempo, a soft, periodic hush emanating from the darkness. Some pulsars beat slowly, perhaps once per second, while others hum at millisecond intervals, their fast pulses blending into an eerie, high-frequency whir. It is as though we are listening to the universe's own clock, keeping time with the spinning of a shattered star. For instance, at the heart of the Crab Nebula, itself the remnant of a supernova observed from Earth in 1054, lies a pulsar that blinks dozens of times each second. Long after the giant star's death, this tiny core continues to flash its beacon, a cosmic heartbeat still audible across space. It reminds us that even after catastrophic endings, a steady rhythm can emerge, carrying on the story in a new form. Not all neutron stars are so regular and gentle. Among these stellar remnants are magnetars, stars with magnetic fields unimaginably strong, billions of times stronger than Earth's. A magnetar rotates more slowly, but its magnetic heart is restless. Every so often, stress builds in its solid crust until it cracks, releasing a sudden flare of high-energy radiation. To us, this would appear as an abrupt spike in brightness or a burst of X-rays, a momentary flash from an otherwise quiet beacon. Magnetars are rarer and behave like cosmic sirens, mostly silent but capable of startling outbursts. One might imagine drifting near a magnetar during its calm phase. It would seem an innocuous, dim star corpse, until an unseen ripple in its magnetic field sends a jolt through space. Though these flares are brief, the power they carry is immense, briefly outshining even other neutron stars. Such events remind us that even in a state of death, these stars can surprise the galaxy with fierce energy. Despite their occasional violence, pulsars and magnetars mostly endure as quiet guardians of the night. They spin on, each a tiny, steadfast light blinking in the dark vastness, often invisible, except to those who know how to listen. Future explorers might use their pulses as guides, navigating by the timing of their flashes, much like ancient mariners used lighthouse beacons. In the emptiness between stars, the regular beat of a pulsar can be a comforting companion, a reminder that something out there is keeping time, marking our passage with its constant rhythm. As we bid farewell to this pulsar, its steady ticking fades into the background of space. We carry with us the knowledge that countless such quiet signals are scattered throughout the galaxy. The remains of long-dead stars continue to send their gentle murmurs into the cosmos, adding a subtle music to the eternal night. Drifting onward, we turn our attention to the material those stars have left behind, the very stuff of new worlds and life, spread out like threads waiting to be woven anew. Now we float through the tenuous outskirts of an ancient supernova remnant, where the once blazing star has dispersed its essence into space. Tiny grains of dust and clouds of gas drift past us, debris enriched with heavy elements forged in that star's core and final explosion. These particles are the seeds and threads of creation, glittering faintly as they ride the interstellar breeze. In their humble silence, they carry the legacy of the star that birthed them, ready to become part of new worlds. Over time, these scattered atoms will wander and mix into giant molecular clouds, the stellar nurseries of the future. Like dye spreading through water, the heavy elements diffuse through vast nebulae, blending with primordial hydrogen and helium. Within these dark clouds, delicate compounds begin to form: carbon dust, silicate grains, even icy molecules. The chemistry of life and planets is stirred into being in these cosmic mixing pots, all thanks to the enrichment from long-gone suns. Gravity eventually draws portions of these enriched clouds inward, causing them to collapse and kindle new stars. As a cloud contracts, it fragments into disks around newborn stars, swirling rings of gas and dust. In those disks, the heavy elements are crucial. They stick together, forming tiny solid specks. Over years and millennia, those specks clump into pebbles, then boulders, and finally into planets, solid worlds built from the ash of ancient stars. We can almost imagine witnessing the birth of a planet in one such disk. Amidst the dim glow of a young star, grains of metal and mineral begin to coalesce, drawn together by gentle collisions and gravity's pull. At first they form swirling bands of dust, then embryonic rocks that sweep up more material in their path. Eventually, a new orb takes shape, a planetesimal growing larger and larger, destined to become a fully formed planet circling its sun. Within these forming planets, elements arrange themselves into familiar substances. Iron and nickel sink to the core, while lighter silicates float upward to make crust and mountains, the rock beneath our feet on worlds like Earth. Some elements combine to create water. Oxygen from old stars meeting hydrogen that has drifted through space since the dawn of time. Comets and asteroids laden with ices can deliver this water to young planets, filling their oceans and rivers with the celestial mix of hydrogen and oxygen. And from these waters and rocks, under the warmth of a steady star, life can spark. The carbon, nitrogen, oxygen, and other elements, all assembled in past stars, become the building blocks of living cells. Every breath drawn by a living creature is filled with oxygen atoms, released by some distant sun's explosion eons ago. Every sip of water contains hydrogen from the Big Bang and oxygen from a star that died long before Earth formed. The food that sustains us, the calcium in our bones, the iron in our blood, all were forged in cosmic furnaces and scattered across space, only to be gathered here and now into us. We are literally made of stardust. It's a simple phrase, yet contemplating it fills us with wonder. Looking out into the cosmic night, we feel a profound kinship with the stars drifting around us. Those shimmering lights are not just distant suns. They are our ancestors in a sense, contributors of the very matter that composes us. Across the light years, an unbroken chain links the first generations of stars to our own bodies, tying our existence to the life cycles of the cosmos. The heavy elements are the threads in the grand tapestry of creation. They weave through time and space, stitching together the lives of stars, planets, and living beings. In the quiet of this interstellar voyage, we can trace one of these threads. From the fiery heart of a supernova long ago, through drifting nebulae, into a newborn star system, and finally into the rocks, oceans, and biosphere of a planet. It is a continuous story of matter and energy, recycling endlessly and knitting the galaxy together in a web of cosmic heritage. Even exceptionally rare cosmic events add to this story. When two neutron stars collide in a spectacular merger, they forge heavy elements like gold and platinum in the ensuing blast. These treasures, too, are cast into space, joining the diffuse mix of stardust. The next generation of stars and planets will inherit those precious atoms, incorporating them into new worlds and perhaps new living beings. As we continue our journey, we carry the awareness that every star we pass contributed in some way to the richness of the universe. The gold tint of a distant star might hint at the heavy elements it has made, and one day will give back. The dark dust lanes between stars are not emptiness at all, but cradles of potential, filled with the raw material for future suns and worlds. In this way, the galaxy regenerates itself, each generation of stars handing off the torch of elements to the next, in an endless cycle of death and rebirth. Our own sun and its planets are beneficiaries of this cycle. Before our solar system existed, several stars lived and died in this region of space, enriching the nebula from which the sun was born. Because of them, Earth had the ingredients for land, sea, and life. In gratitude, we acknowledge those unseen predecessors, the long extinguished stars that enabled our world to bloom. And we realize that someday, in the far future, material from our sun will join the interstellar medium, continuing the thread for new cosmic creations to come. Leaving behind the fading nebula, we soon encounter a gathering of stars that stands out against the solitary ones around. There is a loose cluster here, dozens of suns moving through space in unison, like a flock of birds traversing the sky. It reminds us of the Pleiades cluster seen from Earth's skies, a sisterhood of stars bound on a common journey. They shine predominantly with a youthful blue-white hue, indicating they are young stars, likely born together from the same cloud not too long ago. This is a stellar family, an association of siblings drifting together on the great galactic journey. As we glide amidst this group, we notice the subtle gravitational dance binding them. Each star in this family influences the others slightly, their mutual gravity keeping them moving along a similar path. They are not tightly packed like a globular cluster, but rather loosely scattered over many light years, a kind of extended family that is gradually spreading out. Now and then, one star strays a bit farther from its siblings, a preview of the eventual fate where this family will disperse across the galaxy. For now, though, the stars remain recognizable as kin. We imagine that if we could trace their past orbits, they would converge to the same birthplace, a nebula that has long since dissipated. Perhaps remnants of that birthplace still linger as faint wisps of gas around us, but largely these stars have left their nursery behind. They carry with them the same age and chemical fingerprint, a signature of their common origin, shining as living proof of their shared chapter of birth. Some star clusters stay together only for a short time before dispersing, while others can remain bound for hundreds of millions of years. Eventually, interactions with passing stars and the tidal forces of the Milky Way will gently pull these siblings apart. One by one, they will wander off, blending into the broader star population. But even as they drift away individually, their shared motion can still be detected ages later as a subtle stream of stars moving in the same direction through the galactic sea. Only the most tightly bound clusters, such as the massive globular clusters that hover in the galaxy's halo, can hold on to their stars for many billions of years. Indeed, astronomers on Earth have discovered such streams, former clusters stretched into rivers of stars by time and gravity. These stellar streams are like cosmic fingerprints, revealing where a group of stars came from as they snake across the sky. They are harder to spot than obvious clusters, but careful mapping of star motions uncovers their presence. Hundreds of stars spread out over vast distances, yet all travelling as if remembering an ancient bond. It's a reminder that family ties among stars can persist even after the family home is gone. As we accompany this particular stellar family for a while, we reflect on our own sun's story. The sun, too, was born in a cluster with siblings. Over billions of years, that cluster dissolved, and our sun's sisters and brothers drifted far away, scattered unseen among the myriad stars. Somewhere out there in the galaxy, there may be stars very much like the sun, sharing its age and composition, long-lost solar siblings, now strangers light years apart, but forever linked by their origins. Eventually, we bid farewell to the star family. As we ease out of the cluster's domain, the stars behind us begin to spread out again into the more random background distribution. We watch the cluster's bright members gradually blend into the starry panorama, their special cohesion becoming less obvious with distance. Ahead lies a quieter stretch of space, a gap between the spiral arms where stars are fewer and the darkness deeper. Drawn forward, we transition into this calmer region, ready to experience the peace of the interarm void that awaits. We have entered a quieter stretch of the galaxy, a broad expanse between its spiral arms. Here, the crowd of stars thins out, and the clamorous activity of star birth dies down. The backdrop of space grows darker and more vast, punctuated only by solitary stars glimmering at great intervals. It is a peaceful, cosmic ocean, a dim lane of tranquility where one can truly sense the immensity of the void between bustling starlit regions. Drifting through this interarm space, we feel a deep calm enveloping our journey. Without the glare of numerous young stars or nebulae, the darkness is purer, starlight more subtle. Each star we do encounter stands alone, like an isolated lighthouse on a quiet sea. Many of these are older, amber-coloured suns that have long outlived the vibrant clusters of their youth, now keeping solitary watch in the darkness. In these sparsely populated regions, distances between neighbouring stars can be vast. A single star might shine for light years around without a close companion, reigning over its little pocket of space in solitude. If such a star holds planets, those worlds experience an especially profound isolation, with no nearby suns dominating their night skies. One can imagine a planet here enjoying eons of undisturbed existence, far from the crowded, disruptive events of the spiral arms, a tranquil haven for life to quietly evolve if it takes root. The interarm realm offers a splendid view of the galaxy's structure from within. Looking to the side, we see the soft glow of a distant spiral arm, a pale band of light made by countless stars, like a far-off city seen across a dark plain. Above and below, the universe beyond the Milky Way becomes more visible too. The curtain of our galaxy's dust thins here, revealing more of the deep black sky studded with faint galaxies. It is as if we have stepped out of a forest into a wide clearing, allowing us to gaze further into the cosmic horizon. This calm galactic wilderness invites reflection. In the relative emptiness, the mind wanders as freely as our vessel, contemplating the journey so far. We recognize that our own sun resides in a region much like this, a quiet spur between major arms. And perhaps it was this peace that gave life on Earth the stability to flourish. We feel gratitude for these interarm sanctuaries, the wide and gentle spaces that balance the galaxy's dynamic hubs of activity. There is beauty in this simplicity, just the darkness and the distant pinpoints of light. Without the distraction of dense star clusters or glowing clouds, each star here tells its own story into the silence. We pass by a red giant drifting alone, its faint light a reminder of the eventual destiny of many stars, including our sun. We then spot a tiny, dim red dwarf, one of the most common star types, living out an unimaginably long life, unnoticed in these quiet corridors between the arms. Time seems to slow in this vast, still expanse of the galaxy. Without dramatic changes in scenery, we become attuned to subtle emotions, the gentle drift of our craft, the distant rotation of the galaxy itself. Stars move here too, but their dance is measured and stately, free from the jostling crowds. It is a perfect interlude for us, a chance to simply be, floating in a soft starlight dusk that bridges the brighter chapters of our voyage. As we traverse this dim lane, a new sight gradually comes into focus ahead. Far on the horizon of our journey, beyond the quiet expanse, we detect a subtle brightening. It stretches across our field of view in a faintly glowing strip, the first hint of the galaxy's central bar revealing itself from afar. Though still distant, this elongated glow signals that we are drawing nearer to the inner regions of the Milky Way, where new wonders await beyond this calm interlude. Gradually, the character of our surroundings begins to change once more. After the relative emptiness of the interarm gulf, we notice the star density ahead of us is subtly increasing. More stars appear in our forward view, not randomly scattered, but seeming to align in a broad band that stretches across space. This faintly luminous band is the first whisper of the Milky Way's central bar, making itself known from afar. Unlike the curved spiral arms we traversed before, the structure ahead has a different geometry. It is straighter and more elongated, a spine of starlight cutting across the galaxy's heart. We see it at a gentle angle, not straight on, so it presents itself as an extended glow that gradually brightens toward the center. It is as if we are approaching a cosmic beacon, a long, glowing bridge of stars that links one side of the galaxy to the other through the core. The stars that form the bar are numerous and densely packed compared to the quiet region we just crossed. Their combined light creates a diffuse golden haze in the distance. Many of these stars are older, giving the bar a warm, yellow-white coloration distinct from the bluish tint of the star-forming spiral arms. Through our view, it resembles a far-off sunrise stretched horizontally, heralding the more crowded regions to come. Even though we remain some distance from the bar, its gravitational influence is already evident. We can feel our trajectory subtly drawn by the mass concentration ahead, like a gentle tug guiding us inward. Gas clouds in this vicinity also respond, flowing along the bar's length toward the galactic center. This large-scale channel of stars and gas acts as a highway, funneling material into the core, and we are now on its outskirts. For centuries, from our vantage on Earth, the existence of this bar was only hinted at by the motions of stars and the distribution of light in the sky. Now, as we sail within the galaxy itself, the bar's form becomes clearer with each passing light year. It spans ahead of us like a subtle bridge of light, difficult to discern at first, but growing more defined the closer we get. There is a feeling of entering a new domain of the Milky Way, the realm of the inner galaxy, announced by this glowing omen on the horizon. We travel further, and the elongated band of starlight intensifies. Off to our sides, we can make out where the bar's ends meet the bases of spiral arms, regions marked by clusters of young stars, ignited by the bar's influence. Those junctions are like bright capstones on each end of the bar, but straight ahead lies the bar's midsection, leading directly toward the galaxy's core. The very center of the Milky Way is concealed within that radiance, still hidden from our eyes, but unmistakably close now. The far signal of the bar has done its job. It has guided us through the emptiness and toward the galaxy's central hub. What was once just a faint suggestion of light has grown into a prominent feature, dominating the forward sky. Our anticipation builds as we prepare to follow this starlit road inward. The sights and mysteries of the galactic core beckon us. But first, we must pass through the gateway, where the bar leads into the very heart of the Milky Way. Ahead, where the constellation Sagittarius points the way, we sense an opening, a transition from the bar into the core. It is like approaching the gates of a great city after a long journey through open country. The stars ahead form a brighter congestion, and within that convergence lies a crossroads of cosmic pathways, the meeting of the bar, the spiral arms, and the central bulge. With the gentle light of the bar now all around us, we set our sights on this inner threshold, ready to enter the gate of Sagittarius and the mysteries that lie beyond. We now approach the gateway to the galactic core, guided by the arcing light of the bar into a region rich with stars. All around us, the stellar density increases dramatically, points of light multiplying against the darkness until they merge into a diffuse golden glow. This is the Sagittarius Gate, an entryway marked by a broad swath of densely packed stars, the Sagittarius star cloud, signaling our transition into the Milky Way's bustling center. What was once distant and faint now envelops us. We are gliding into the very thick of the galaxy's heartland. Despite the growing brilliance of our surroundings, our approach remains gentle and unhurried. We slip softly into this inner sanctuary, like a swimmer easing into sunlit waters. Star after star drifts past, each one closer to its neighbours than any we have seen before, yet still separated by immense gulfs in human terms. The light here is a continuous radiance, as if night has given way to a constant stellar dawn from every direction. The inner crossroads is an apt description. Here the structures of the galaxy truly converge. Behind us, the long stellar bar funnels into this zone. To our sides, the spiral arms curl in, their innermost ends dissolving into the general bright mass of the central bulge. We can imagine these streams of stars as highways feeding into a grand cosmic interchange. The dynamics are complex. Stars from various origins mingle here, moving under the strong gravitational pull of the central mass. Yet from our tranquil vantage, it feels like the calm center of a cosmic whirlpool. The stars in this region are of all ages and types, though the giants of old and dense clusters of ancient suns stand out. Occasionally, a burst of youthful energy shines where gas has pooled enough to spark new stars, even in this crowded environment. But overall, the light has a mature character, a composite glow of billions of long-lived stars swarming the core. Dust lanes weave through the starlight, forming faint dark ribbons that remind us of the galaxy's complexity, even here at its hub. There is a subtle change in the very fabric of space as we move closer to the nucleus. The gravitational field grows stronger, the motions of stars more rapid. We sense that we are nearing something powerful, something that anchors all these orbits. Though we cannot yet see it, the presence of the galaxy's central black hole lurks ahead, an unseen conductor guiding this crowded symphony of stars. We approach with respect and awe, maintaining our slow pace to absorb the grandeur rather than rush through it. Passing through the Sagittarius Gate, we find ourselves within a dense stellar metropolis. Clusters of stars, akin to cosmic neighborhoods, drift by, some so packed that they resemble sparkling beehives. One moment we glimpse a tight globular cluster on the fringe of the bulge, and the next we slide past fields of red giants dispersed like streetlights in the galactic dusk. Everywhere we look, stars crowd the sky, their collective light bathing us in a gentle luminescence. In spite of the density, there is a hush to this inner region, a silent grandeur. The vast scale diffuses any sense of chaos. From our perspective, it feels serene, like drifting through an endless city at midnight, lights glittering all around. We navigate carefully, aware that this is the Milky Way's deep interior, where the histories of countless stars overlap. This is a place where the journeys of many stellar families end and begin, all paths crossing in the nexus of the galaxy. We have arrived at the threshold of the galactic center. Ahead lies the very heart of the Milky Way, a place of mystery and extremes that beckons us onward. Our odyssey so far has carried us across spiral arms and silent voids, past newborn stars and ancient remnants, all leading to this convergence point. With starlight surrounding us on all sides, we prepare to venture further in, ready to uncover the secrets waiting in the glowing core beyond this gateway. As our journey continues, we come to a gentle stop amid the soft radiance of the inner galaxy. Here, near the boundary of the central realm, we allow ourselves a moment of stillness. The cosmic landscape around us is breathtaking. Behind us, the dense golden light of the galactic core still pours forth, and ahead of us lies the darker expanse of the spiral arm beckoning outward. We are suspended in a balance. In front of us, darkness and open space. Behind us, warmth and brilliance. In this quiet juncture, we simply float and absorb the scene, letting the enormity of it settle into our being. There is a profound serenity in this pause. After journeying through so many wonders, the dust veils, the star city, the silent black hole, the echoing flares, it feels as though the galaxy itself is giving us a moment to reflect. The inner glow bathes us gently, like the fading light of a long sunset. We sense the balance of forces here, the pull of the central gravity and the stretching reach of the spiral arms. In this calm, one can almost hear one's own thoughts echo against the vastness, as if the universe is quietly listening. At this juncture, it's natural to ponder our own place in this immense cosmic structure. Somewhere far ahead, out in the darkness of the spiral arm, our home star circles the galaxy. From here, that sun, and all of human history with it, is just an invisible speck lost in the vastness. The perspective is both humbling and comforting. We realize how far we've conceptually traveled from that tiny corner to this luminous core. And we marvel that despite the scale, the light from billions of stars now surrounds us, making this remote outpost feel almost welcoming. It is a reminder that though we are small, we are part of something wondrous and grand, connected by the starlight that fills this space. We take a mental breath and focus on the sensations of this moment. No winds blow here. No sound reaches our ears. Just a sublime silence envelops us. The light itself seems to have texture, a diffuse golden hue from behind, and a faint blue darkness ahead. The contrast is beautiful. It's as if we stand at twilight between day and night, at the meeting point of brilliance and void. In this stillness, every glimmer from a distant star feels meaningful. We are immersed in the calm heartbeat of the galaxy, a slow, silent pulse that can be felt if one listens with the soul. We know our journey is not over. This pause is a gathering of strength, a quiet interlude before we venture onward. In our mind's eye, we imprint the vision of the glowing galactic heart we are leaving, its lights, its mysteries, its profound calm. We hold that image gently, as one holds a cherished sunset before night falls. With that inner eye still seeing the glow, we turn slowly toward the beckoning darkness of the outer galaxy. We carry with us the warmth and lessons of the inner sky as we prepare to step into the wide and open cosmic sea beyond. Slowly, we ease away from the central realm and begin our outward journey along the spiral arm. The grip of the galactic center releases us gently. Its strong gravity and bright light gradually recede. Behind us, the brilliant congestion of stars starts to compress into a glowing core, growing smaller and softer with distance. Ahead, the path opens into the wide galaxy beyond, a stretch of stars and nebulae that winds away on a grand scale. We are turning to the wide expanse now, leaving the crowded nest of the core for the more spacious domains of the disk. With each passing light year, the character of our surroundings changes. The once all-encompassing glow of the inner galaxy fades into the background, and darkness returns to the forefront. Individual stars become more discernible, punctuating the night instead of overwhelming it. In the spiral arm, the stars are more scattered. Vast gaps of interstellar space stretch between stellar clusters. After the near-constant radiance of the core, the deeper nights out here feel both tranquil and stark. The gentle illumination that remains comes from the combined light of far-off suns and the faint shimmer of nebulae along our route. We glance back over our shoulder, so to speak, at the galactic center we have left. It now appears as a concentrated glow in the distance, the central bulge of the Milky Way shining like a lantern in the vast dark. What was once our encompassing environment has become an object on the horizon of our journey. The core's golden light still guides us from behind, but it is mellowed by distance. We carry the memory of its warmth as we move further away from it. Forward, the spiral arm guides our path, curling gracefully and inviting us deeper into the outer regions. Ahead, the vista opens wide. Stars dot the sky like distant campfires, and here and there we see the faint hazy patches of star clusters and glowing clouds, the stellar nurseries and remnants that populate the spiral arm. Without the overpowering glare of the core, these subtle features come into their own. A blue-white star blinks on our left, part of a nearby cluster. To the right, a tenuous veil of gas catches the light of several young suns, hinting at a nebula cradled in the arm. The cosmic ocean of the outer galaxy spreads before us, vast and beckoning, full of sights both gentle and majestic. We can feel, in a figurative sense, the center's embrace loosening. The gravitational pull that once dominated our journey wanes with distance, and we float a bit more freely in the arm's expanse. There is a sense of liberation, but also of leaving a place of warmth and heading into a cooler, quieter frontier. Just as a traveller might leave a bright city and venture into open countryside under the night sky, we are doing the cosmic equivalent. The road ahead winds outward, and the gentle tug of the galaxy's spiral will guide us now. The center has let us go, sending us onward with its faint light at our back. With the core behind us and the unknown ahead, we set our sights on the great spiral road unfolding in front of us. The journey continues, gently carrying us outward into the wide expanse of the galaxy. As we drift further from the center's embrace, the starry panorama grows even broader, and the mysteries of the spiral arms await our quiet exploration. Buoyed by the memories of the inner galaxy, we move forward into the cosmic night, one with the endless starlight and infinite possibilities that lie before us. It is the next chapter of our cosmic voyage, waiting to unfold. Our journey inward continues as the starlight around us begins to soften and fade. Ahead, enormous clouds of cosmic dust loom like dark curtains drawn across the galaxy's central stage. These are the great dust lanes, broad rivers of interstellar dust and gas that wrap around the galactic heart in shadow. They drift silently, obscuring our view of the brilliant core hidden behind them. In their presence, the once bright star fields dim into a gentle twilight, and a hushed darkness falls as we venture deeper. Entering one of these dusky corridors, we find ourselves enveloped in starlight that has been muted to a faint glow. It is as if we have slipped into an ancient, vaulted tunnel, carved from night itself. Stars behind the dust appear as blurry, coppery embers peeking through a veil, their light scattered and reduced to a subtle glow. The dust around us is cold and still, a silent fog of tiny particles that have drifted here over eons. In this quiet darkness, our senses attune to the delicate presence of the dust. Millions of grains suspended in space, forming lanes that stretch for hundreds of light years. They chart hidden pathways toward the galactic center, like secret rivers flowing ever inward. As we glide along this shadowy route, the sense of direction comes not from sight, but from the faint pull of gravity drawing us forward. The dust lane guides us gently, curving through the inner galaxy in a path known only to it. Within these obscuring bands, new stars occasionally spark to life, born in pockets where the dust and gas grow dense enough to ignite. But their newborn light is quickly muffled by the thick surroundings, only a soft halo betraying their presence. For a moment, we catch the subtle gleam of one such hidden nursery, a faint glow off to our side, like a lantern shining behind heavy curtains. There, a cluster of infant suns gathers, their collective light barely piercing through the swaddling dark that surrounds them, hinting at the new life forming in secrecy. We imagine these dust lanes as the arteries of the galaxy, carrying material inexorably toward its heart. All around is calm and dim. The chaos of starbirth happens quietly behind curtains, with only a subdued glow to mark its place. Deeper into the dust, we notice rare clearings, brief windows in the veil where a few bold rays of starlight slip through. Through one such opening, far ahead, we catch a tantalizing glimpse of something radiant. It's like peering down a long, dark corridor to see a distant light at its end. We realize this faint glow is the promise of the galactic core itself, peeking around the edges of the dust clouds. The path we follow is winding, and each turn reveals subtle shifts in the darkness. One moment, we are wrapped in nearly complete night. The next, a ghostly glow outlines the silhouette of the dust around us. It is as if the galaxy is teasing us with glimpses of what lies beyond its veils. We carry on with patience, drifting further in, letting the darkness gradually give way. At last, after a long, gentle traverse, the heavy shroud of dust begins to thin. The void around us grows subtly brighter, the darkness easing into a deep amber glow. We emerge slowly from the dust lane's embrace, as if walking out of a cave into twilight. The shapes of swirling clouds fall behind us, and ahead an expansive brightness dawns. There, stretching across the inner sky, is a vast congregation of stars crowded together. After the quiet dark, the sudden richness of light is breathtaking. We have arrived at the threshold of the galactic heart, where the dust lanes end and a brilliant city of stars begins. To think, these dark veils that block our view are also the wombs of new stars. Within their secret depths, the next generation of the galaxy's lights will one day spark to life. Passing through them, we are reminded that even in darkness, creation is quietly at work. The hidden corridors of dust are not empty. They are filled with promise, carrying the raw ingredients that will ignite into brilliance. In the stillness of this shadowed realm, we sense the slow, patient stirring of the galaxy's future. Now, as we emerge from the veil of dust, we find ourselves immersed in a great city of stars. All around us, an immense multitude of suns illuminates space, their collective light weaving a tapestry of gentle radiance. The sky here is dense and alive. Wherever we look, starlight glitters, leaving hardly any gaps of true darkness. In this galactic downtown, stars crowd together by the millions, as if they were city lights on an endless night. Their glow is steady and reassuring, bathing the surroundings in a perpetual soft luminosity that feels both mysterious and welcoming. Drifting deeper into this stellar metropolis, we begin to discern structure amid the glow. The stars are not scattered at random, but form a grand cosmic architecture. Some regions bloom with tight clusters of brilliance, neighborhoods of stars packed closely, shining as a single concentrated jewel of light. Within these clusters, massive young stars blaze blue-white, brief but intense, adding pinpoints of diamond-white light to the golden background. Scattered among them are the elder residents, countless red giants and ancient suns with a softer amber hue. Tucked among this throng are exotic stellar remnants as well, quiet neutron stars and black holes left from earlier generations. But they too are lost in the glow, invisible amid the brilliance of the living stars. Their combined light paints the core with a warm, honeyed tone, as though an eternal dusk has settled here. Through this glow, faintly luminous nebulae wind between the stars, like slow-moving traffic through city streets. We see hints of glowing gas and dust lit from within, forming wispy silhouettes that arc gracefully around clusters and bend into delicate curves. Indeed, across the crowded core, we notice grand arcs of starlight and glowing clouds tracing gentle loops. One sweeping band of light drapes itself across our vista, perhaps a stream of stars or a cloud of ionized gas shaped into an elegant curve. It spans the view like a celestial bridge, linking different parts of the star city with a subtle glow. Such luminous arcs create the impression of grand avenues in this cosmic metropolis. They suggest an underlying order, hidden amid the starry abundance. Though delicate and fleeting to our eyes, these features hint at powerful forces quietly at work. It is the gentle tug of gravity over eons, sculpting matter into graceful patterns at the galaxy's heart. Everywhere we look, the sky is crowded, yet serene. If we imagine standing on a world within this region, its night would never be truly dark. So many stars would hang in the sky that even at midnight, the heavens would glow like twilight. The concept of a lonely night, as we know it near our own sun, would be foreign here. Instead, an everlasting stellar twilight would reign, with dozens of brilliant stars casting subtle shadows in all directions. It is a beautiful, overwhelming brightness, yet it does not blind or fatigue us. It simply surrounds us, a gentle white gold haze permeating space. Though silence dominates, one can sense an undercurrent of energy in this place. Stellar winds and faint traces of cosmic rays wash through the core, stirred by the collective outpouring of so many suns. Wisps of nebulous material drift under the influence of these forces, glowing softly as they absorb and re-emit starlight. Here and there, a distant star might reach the end of its life and gently fade away or explode in a brief flash, an event that might occur perhaps once in a century in this vast hub, like a single firework in an otherwise quiet night. Yet even such a flare would be swallowed by the greater radiance around it, its effects visible only as a subtle change in a nearby nebula, or the appearance of a new pinprick of light where darkness was before. As we gaze toward the very center of this crowded sphere of stars, we sense a subtle shift. The innermost region ahead grows even more intense with starlight, but also strangely void at its absolute core. Countless stars orbit ever closer to an unseen focal point, moving as if choreographed by an invisible conductor. There is a curvature to their collective motion, a suggestion that they are circling something we cannot yet see. In the heart of this luminous city lies a darkness, a small patch where no star resides, where the light seems to swirl around an empty center. It is there that the deepest mystery of the galaxy rests. Within that quiet central void, there is an object that does not shine at all, yet its presence is felt in the graceful dance of all the stars around it. We prepare to venture into that silence, toward the gentle gravitational well that anchors this stellar city. In the silence of this gravitational abyss, we contemplate the universe's capacity for extremes, a place where matter and light surrender to gravity, leaving only a profound quiet. There is both dread and solace in this notion. Dread in the absolute finality of the black hole's hold, yet solace in its steady, unwavering presence. It is a paradoxical monument, born of violence, now an agent of cosmic order, holding the surrounding chaos in a calm embrace. We drift in awe near this dark center, filled with respect for the balance it maintains in our galaxy. We drift closer to the galaxy's silent heart, where the brilliance of starlight gives way to a soft, eternal night. Here, in the innermost sanctuary of the Milky Way, a profound hush prevails. There is no storm of light or sound, only a deep and gentle pull that tugs at us from the darkness ahead. It is as though we have entered a cosmic stillness, a place where all the noise of creation has fallen away. In this quiet void, we feel the presence of the central gravity, immense and unwavering, yet utterly silent. At the very center of this great city of stars lies a supermassive black hole, an object of unimaginable density and calm. It holds the mass of millions of suns, crushed into a space no larger than a dot against the vast sky. In fact, the surface of this black hole, its event horizon, might span only a few million kilometers, smaller than our solar system. Yet we cannot see it at all. It neither shines nor burns. It simply is, a heavy emptiness distorting the space around it. Its gravity dominates the core, gently steering stars and gas in their paths, but it remains a void in the midst of abundance. We recognize that despite its darkness, this black hole is the keystone of the galaxy's heart, anchoring the swirling dance of stars around it. Drawn in by its gravity, we approach the edge of the black hole's influence with reverence. There is a boundary here, invisible but absolute, called the event horizon, the point beyond which nothing that enters will ever return. If a beam of light strays too close, it will curve inward and vanish, lost to the world outside. Anything crossing that threshold disappears, as if swallowed by a bottomless well. The notion is both eerie and strangely peaceful, falling into such silence with no sound, no fanfare. We remain safely distant, but the awareness of that one-way boundary sends a quiet awe through our minds. Time itself seems to slow as we contemplate this gravitational abyss. Near the black hole's edge, moments stretch and nearly stand still from an outside perspective. If we could hover just above the event horizon and look out, the universe beyond might race on fast forward, while we linger in almost frozen calm. But here, observing from afar, we simply sense that unhurried nature of time in the black hole's vicinity. It is a place where clocks lose meaning, where a minute outside could be an eternity near the brink. This dilation of time is another voice in the silence, an inaudible, slow heartbeat marking the presence of extreme gravity. All around the black hole, space itself is curved and serene. We notice that the starlight behind it is subtly bent, warped into rings and arcs by the intense gravity, forming a delicate halo of light if viewed at just the right angle. It is a gentle lensing effect, barely visible but real, as if the black hole wears a faint halo made not of its own light, but of light it has borrowed and bent from elsewhere. This gravitational mirage is one of the only signs of the black hole's existence, aside from the motions of the stars themselves. Mostly, it hides in plain sight, perfectly black against the backdrop of shining stars. Despite the power of this dark gravity well, its demeanor is calm. Unlike the ferocious black holes in distant galaxies that blaze with torrents of energy, our galactic center's giant is largely quiet. It feeds very little, sipping only occasionally from stray clouds of gas or the rare wandering star that ventures too near. When such infrequent feasts occur, they cause only a gentle stir, a brief flicker of X-ray or radio waves that soon subsides back into stillness. For the most part, the black hole rests in a kind of deep slumber, content to simply hold the galaxy's core together without fanfare. As we float here on the outskirts of the black hole's dominion, we feel a sense of profound respect. In the presence of such an entity, we encounter one of the universe's great paradoxes, an object immensely powerful, yet utterly silent and invisible. The black hole's gravity cradles us from afar, steady and unyielding. But there is no malice or violence apparent in this moment. It is simply the nature of gravity to pull, and the nature of this black hole to be the anchor. We allow ourselves to drift in this gentle curvature of space, as if leaning over the rim of a vast, dark well and peering into its depths. This is the gentle gravity of silence at the galaxy's core. It is the soft pull that keeps the stars circling in their cosmic ballet. It is the quiet center that listens to the rest of the galaxy without ever uttering a sound. In this moment, we are witnesses to stillness on a colossal scale. The black hole remains before us, a mystery wrapped in darkness, calmly shaping the world around it. With our hearts and minds quieted by its profound silence, we prepare to look outward again, toward the stars that dance at the edge of this gravity, tracing graceful orbits like celestial calligraphy around the void. We turn our gaze to the stars circling this quiet void, watching as they trace their paths with elegant urgency. Dozens of stars, some of them among the fastest in the galaxy, are locked in a dance around the invisible black hole. Against the darkness, their movements become apparent as gentle streaks of light, if we imagine time sped up. Each star glides along its orbit like a pen stroke on a cosmic page, looping around the center and then sweeping back out toward the outskirts of the cluster. From our perspective, their trajectories interweave in 3 dimensions, creating an intricate, ever-changing script written in starlight. One star in particular catches our attention as it dives inward on a steep, elliptical path. For long years, it has climbed away from the center, slowing at the far end of its orbit, and now it falls back toward the black hole with increasing speed. As it nears the unseen mass, it swings around swiftly, making the tightest turn in its journey. In a matter of mere hours, at closest approach, it zips through space at incredible velocity, for a moment moving at a few % of the speed of light, then slingshots away, back toward the outer reaches of the core. This single loop, taking perhaps only a decade or 2 to complete, is like a brilliant flourish in the stellar calligraphy. It's astounding to think that within a human lifetime, this star will have drawn a full, elegant ellipse around the black hole. Each of these fast-moving stars carves out its own unique story. Some follow elongated ovals that bring them very near the black hole before flinging them far out again. Others trace more circular paths, steadily revolving like planets on fast forward. Their orbits tilt at various angles, overlapping and crossing without collision, each star minding its own path, as if choreographed to never meet. If we could see their entire trails glowing at once, space would be adorned with loops and whirls of light, a luminous calligraphy written over centuries. Every loop is a chapter, every close approach a dramatic pen stroke in this celestial manuscript. In the vicinity of the black hole, gravity shapes not only space, but also the flow of time. When these stars swoop in close, time for them slows ever so slightly in the grip of the intense gravity, then resumes its normal pace as they retreat. To our distant eyes, the effect is nearly imperceptible, perhaps a subtle redshift in the starlight, or a tiny delay in their clockwork rhythm. But it is there, a soft bending of time accompanying their dance. It is as if the cosmos itself draws these orbits with a gentle, deliberate hand, making sure each stroke is precise, despite the warping of space and time. The stars carry on, unaware of these relativistic nuances, moving to the silent music of gravity. Watching this choreography, we feel a sense of continuity and rhythm. Decades pass in these loops, but in the grand scale of the galaxy, it all unfolds in a graceful cadence. The fast stars near the center complete their circuits in a few tens of years, while those slightly farther out take centuries, and the ones beyond blend into the slow rotation of the galactic bulge that may last millennia. It's a cosmic timepiece, with each star as a ticking hand, some racing, some leisurely, yet all synchronized by the central gravity. The orbits overlap eras, a pattern drawn over ages, yet always fluid and alive in the present. As we linger on this spectacle, we appreciate how these looping paths reveal the invisible master at the core. Long before humans ever saw a black hole directly, it was the precision of these star orbits that whispered of its existence. With each completed circuit, the stars effectively mark the presence of the dark mass, sketching out the boundaries of its realm through their motion. In a way, The black hole's signature is not written in light, but in the swirling calligraphy of these orbiting stars. They are the faithful scribes of the galactic center, endlessly rewriting the story of gravity's grip with every turn. After absorbing the elegance of these orbital patterns, we begin to shift our perspective once more. Our attention moves outward, beyond the immediate circle of the black hole's dancers. We recall that much of what transpires here is hidden from normal sight, cloaked by distance and dust. To truly perceive the subtleties of this inner realm, we must change the way we observe. Gently, we prepare to tune our senses away from visible light and into other, more sensitive forms of perception. To listen in warm radio waves and to see in the soft glow of infrared, unveiling the secrets that our eyes alone cannot see. We gradually shift our perception beyond the visible, tuning in to the universe's more subtle whispers. Our eyes, which have been our guides, now yield to other senses. We begin to listen in the realm of radio waves, and we open an inner eye to the infrared glow. In doing so, the hidden facets of the galactic center gently emerge. The dust and darkness that once veiled our view become transparent. The void fills with new information. It is a patient form of seeing and hearing, requiring us to slow down and let the faint signals collect. In this warm radio hum and cool infrared glow, the unseen becomes seen. Adapting to these new senses teaches us patience. The radio whispers arrive slowly, so we must listen over long moments to piece together their meaning. And the infrared vision requires us to notice subtle heat instead of glaring light. This shift in perception is almost meditative. We have to slow down and attune ourselves to the galaxy's quieter voices. By doing so, an unseen layer of the cosmos is revealed, one that was always there, waiting for us to pay attention. In the radio spectrum, we sense a soft background chorus from the galactic heart. Instead of silence, space is alive with a quiet cosmic hum. The supermassive black hole that was invisible to our eyes now makes itself known as a gentle radio source, a constant murmur in the dark. We detect the faint hiss of particles spiraling through magnetic fields and echoes of past events resonating at long wavelengths. Long, thin filaments of energy stretch outward from the core, structures we could not discern before. These cosmic threads glow softly in radio waves, hinting at ancient outflows or hidden magnetic fields shaping the inner galaxy. Each signal arrives across the eons, and we listen patiently, piecing together a picture of the galactic center drawn in these invisible frequencies. Meanwhile, our view in infrared pierces the dust, unveiling a new panorama. The crowded city of stars shines even more brightly in this light. Countless suns, once hidden behind dust clouds, now burn clearly, their intense light shifted into a soft red glow. The entire scene is transformed in color. Hot young stars that once blazed blue now appear white gold, while cool red giants deepen to a rich amber. The dust that obscured them also radiates softly, warmed by starlight absorbed. What was cold and dark to our eyes is now suffused with a subtle luminance. Nebulae that were black silhouettes turn translucent, revealing vast, winding clouds that weave through the core. It is as if a veil has been lifted, exposing the bustling activity and structure that were always present. With infrared sensitivity, we discern patterns in the dust and gas. We notice that these clouds form complex, overlapping structures, circling the center like a grand maze. Some regions shine with the faint blush of new stars, forming within cocoons of gas. Here and there, we catch the dim glow of molecules excited by nearby starlight, signaling chemical complexity in places we previously only sensed as void. The infrared view also unveils subtle temperature differences. Warmer patches where stars cluster tightly, or where ancient stellar shockwaves have gently heated the gas, and cooler pockets where dense clouds lie in shadow. Each variation is a clue, a piece of the story of how matter flows and changes in the galactic heart. Having embraced these patient senses, we build a more complete picture of the core. We have listened in radio and heard echoes of phenomena invisible to ordinary light, and we have gazed in infrared to see through dust into the bustling heart within. The image that emerges is one of rich complexity, a core not only bright with stars and anchored by gravity, but also threaded with invisible energies and wrapped in glowing gas and dust. Now, with the darkness peeled back, we find ourselves surrounded by enormous molecular clouds swathing the inner galaxy. These giants form a labyrinth around the nucleus, a maze of gas and dust. It is time to drift further into this molecular labyrinth, to explore the chemistry and calm within those colossal clouds. We slip into one of the colossal molecular clouds near the galactic center, leaving behind the bright hub and entering a realm of twilight. Inside this cloud, the starlight is muted to near darkness. The environment here is profoundly different. It is cold, dense, and tranquil, like the deep interior of an ancient cathedral carved from gas and dust. We find ourselves surrounded by a haze of tiny particles and molecules that drifts gently, barely stirred by any breeze. The outside glimmer of the galaxy is reduced to a faint glow, filtering through the cloud's thick veil. In this sheltered pocket of space, there is a sense of calm and timelessness, as though we have entered a secluded chamber at the center of all the cosmic bustle. These molecular clouds are giants in their own right, spanning dozens of light years and containing mass equivalent to millions of suns, yet spread out as a tenuous mist. Here, atoms and molecules gather in clumps and filaments, forming an intricate maze within the cloud. It is a labyrinth. Long corridors of denser gas wind through vast chambers of thinner material, twisting and branching under the influence of gravity and ancient explosions. The structure is complex and layered, pockets within pockets, clouds inside clouds. And without a guide, one could wander for ages in this dim maze and never emerge, lost among the countless nooks of interstellar dust. The conditions here allow chemistry to unfold at a remarkably unhurried pace. The temperature in the depths of the cloud is extremely low, just a few tens of degrees above absolute zero. In this chill, molecules move slowly, meeting each other only by rare chance. When they do interact, the reactions are gentle and drawn out, taking years or centuries to complete what might happen in moments in a hotter environment. Yet given enough time, even complex molecules can form. We imagine tiny particles of dust acting as cosmic laboratories, their surfaces providing a place for atoms to assemble. Over millennia, simple gases like hydrogen and carbon combine on those dust grains, producing more intricate compounds. Methanol, ammonia, formaldehyde, and even amino acids, the building blocks of life, have been discovered drifting in such clouds. They float silently, accumulating atom by atom in the dark, like a slow chemical artwork coming into being without any haste. Within these molecules lies the potential for life itself, precursors that, someday, could seed new planets with the chemistry of biology. Deeper inside the cloud, away from any stray starlight, the darkness becomes almost absolute. Our surroundings glow only faintly in radio and infrared, offering subtle clues to what lies hidden here. In the radio spectrum, we catch the quiet signatures of various molecules, and in infrared, we detect gentle warmth where dense clumps of gas are slowly compressing under gravity. These dense cores are cradles of future stars, places where someday the cloud's calm will be broken by the birth of new light. For now, they appear merely as slightly warmer spots deep in the cold, not yet bright enough to pierce the veil. They hide like embers in ash, slowly gathering mass until they ignite into stars. But that day is far off, and here in the molecular labyrinth, change comes only in its own time. As we drift, we occasionally encounter regions where the cloud thins out, opening a window back toward the outside galaxy. Through one such gap, we glimpse the distant glow of the galactic center we left behind, a reminder of the brilliant world outside this cocoon. The sight is muffled and reddish, filtered by layers of dust, appearing as a diffuse glow rather than distinct stars. It underscores how effectively these clouds isolate their interior. They are like secluded sanctuaries, where the chaotic events of the galaxy are softened and slowed. Cosmic rays and distant supernova flashes do penetrate, but by the time they reach the heart of the cloud, they are mere whispers of their former selves. In these depths, change comes gently, if it comes at all. A profound hush pervades here, a silence so complete it feels sacred. No starlight penetrates to disturb the darkness, and even molecular collisions are so rare that they make no sound. It is a realm of deep stillness and slow transformation, where time itself seems to stretch. Enclosed by cold clouds and gentle chemistry, the galaxy appears to pause and reflect, honoring the quiet labor of creation unfolding in secret. Despite their tranquility, the molecular clouds are not entirely static. They slowly orbit the galactic center, and on occasion, two clouds will collide or brush past each other, sending subtle ripples through the gas. A nearby supernova long ago might have driven a shockwave through a portion of the labyrinth, compressing it and planting the seeds of future star formation, or a burst from the central black hole may have momentarily bathed the clouds in radiation. These interactions are rare on human timescales, but over millennia they sculpt the cloud structure, bending corridors, opening new chambers, and eventually coaxing some portions of the gas to collapse into stars. The scale of this molecular labyrinth is humbling. Even at our slow, drifting pace, it could take hundreds of years to traverse one cloud from end to end. There are many such clouds here in the inner galaxy, overlapping and abutting one another, collectively forming a massive torus of molecular material around the center. Together, they create a labyrinthine ring that feeds the galaxy's heart. Through narrow gaps between clouds, material gradually flows inward, like a network of rivers converging toward a quiet lake. We sense that these clouds are the reservoir from which the next generation of central stars will be born, and the fuel that might one day awaken the sleeping black hole if enough drifts into its reach. We take a moment to float in this obscurity, appreciating the profound silence and the delicate chemistry unfolding around us. In the dim glow, we become aware that every so often a faint reminder of the galaxy outside finds its way in, perhaps an echo of some distant burst of energy. The cloud might briefly light up in one corner as it reflects a ray of X-rays from a flare long past, or a gentle ripple might pass through from an old explosion's shockwave. These are the echoes upon echoes that hint at events beyond, subtle reminders that even in this hush, the broader galaxy still speaks. Following those quiet clues, we feel the pull to continue outward, to rise from the depths of this cloud and look at the bigger picture. Beyond the shelter of the molecular labyrinth, faint glimmers of past events await our attention. They are echoes of ancient flares and expanding bubbles that billow above and below the galactic plane. Drawn by curiosity, we gently navigate out of the cloud's last wisps, ready to explore the memories of the galaxy's past that hang like ghosts in the space beyond. Rising above the plane of the galaxy, we begin to notice ghostly structures floating in the darkness. High above and below the Milky Way's disk, enormous faintly glowing lobes of energy billow outward like cosmic bubbles. These ethereal formations extend roughly 50,000 light-years from the galactic center, looming over the galaxy's spiral like giant, transparent balloons. They are almost invisible to ordinary sight, but in other wavelengths, gamma rays, radio waves, they shimmer gently, outlining their shapes against the blackness of space. There is a hush and grandeur to them, as if we are seeing the afterimage of a colossal event. These are the remnants of an ancient outburst from the galaxy's heart, echoes upon echoes of a time when the center was not so quiet. We drift along the edge of one of these gigantic bubbles, its surface a tenuous veil of energized particles. The bubble's walls are incredibly diffuse. Even being inside it, one would hardly notice, except for a faint rain of high-energy particles passing by. Yet from this vantage, we can trace its curvature, a graceful arc extending above the galaxy's plane. The faint glow and colossal scale of this structure speak of an event millions of years in the past, perhaps a furious burst of star formation, or a feeding blaze by the central black hole that blasted out these lobes. It is as though the galaxy itself exhaled in that moment, and these bubbles are the lingering cosmic sigh that remains. What remains now is a gentle afterglow, a silent bubble still expanding outward, its edges slowly mixing with the surrounding darkness. Peering into the bubble, we sense how empty it is. The material inside was swept up and pushed outward, leaving a cavity of thin gas. The edges of the bubbles are where the ejected matter has collected, forming a curved shell. Along those boundaries, we detect a subtle brightness, perhaps the fading shock front of the long-ago explosion, still lighting up gas as it plows into the surrounding halo. There is something haunting about this light. It's not the concentrated shine of stars, but a diffuse and ghostly glow, a memory made visible. We realize we are witnessing the galaxy's history written in the sky, just as ripples on a pond mark where a stone once fell. These enormous bubbles mark where the galaxy's center once released a tremendous surge of energy. As we move around the bubble's perimeter, subtle variations come into view. A thin filament extends from the bubble's surface, a tendril of magnetized plasma tracing ancient magnetic fields. And nearby, a patch of the shell glows a bit more brightly, perhaps energized by a cluster of supernova explosions that went off inside the bubble. It feels as if these bubbles hold layers of echoes, not just one event, but a series of reverberations. A powerful burst from the black hole, followed by winds from massive stars, and then their deaths as supernovae, each wave added to the structure we see now. All these contributions blend together into the vast, tenuous shells that quietly continue to expand. Turning our gaze back down toward the galactic center, far below, we notice that even the great molecular clouds we traversed carry faint signs of past drama. Some of those clouds glow with a weak X-ray and radioluminosity that is not of their own making. Instead, they are reflecting energy from a powerful flare, the central black hole unleashed not so long ago. Like a lantern briefly shone into a dark cavern, the flash travelled outward and momentarily lit up the walls of these distant clouds. The clouds have since returned to darkness, but a subtle afterglow still lingers, fading slowly with time. It is a quiet echo of a shout from the black hole that we did not witness directly, a reminder that even in its apparent slumber, the heart of the galaxy can stir. Everywhere we look, the galactic center is filled with these whispers of the past. Arcing above the plane are the monumental bubbles, and closer in, subtle glows and filaments trace the memory of lesser eruptions. Even the distribution of certain star clusters might carry clues, perhaps formed in the wake of past outbursts when shockwaves compressed gas and triggered new stars. It is as though the galaxy remembers its moments of excitement. Each echo is gentle now, no longer the roaring furnace it once was, but the soft ember that remains after the fire has cooled. Floating amidst these remnants, we feel time as a palpable presence. The bubbles above us are still expanding, and will continue to do so for millennia, gradually thinning into invisibility. The reflected light in the clouds below will fade in the decades to come, until those regions fall dark once more. New events may ignite in the future. Perhaps eons from now, the black hole will awaken again, or a burst of starbirth will send fresh shockwaves through the inner galaxy. If so, new bubbles will be blown and new echoes added to this cosmic record. For now, we drift through a gallery of old memories, preserved in faint light and energy, hanging softly in the cosmic night. Having absorbed these silent stories of the past, we gently reorient ourselves toward the galactic plane. Below, the bright disk of the Milky Way stretches out, with spiral arms coiling away from the central region. Our journey continues back into this disk, where we will explore how the inner arms and the central bar connect the bustling core to the wider galaxy beyond. The echoes of ancient flares gradually fall behind us as we descend, and ahead we discern great lanes of stars and dust, bridging the gap between the galaxy's heart and its sprawling spiral arms. It is toward these connecting structures, the bridges between arms, that we now guide our attention. Descending back into the galactic disk, we find ourselves traveling along a broad, shining avenue of stars. This is the central bar of the Milky Way, a vast bridge of starlight that stretches across the inner galaxy, nearly 30,000 light-years from end to end, connecting one side of the spiral to the other. From the bulge at the core, the bar extends outward in both directions, composed of countless stars packed in a gently curving lane. It is as if the galaxy has laid down a luminous causeway, a route by which the dense heart reaches out to the sprawling arms. We drift along this stellar highway, leaving the immediate nucleus behind, but still surrounded by the glow of billions of stars that make up its length. On either side of us, the bar's light scatters into the beginnings of spiral arms. At the ends of the bar, the pathway of stars fans out and bends gracefully, merging into the great curving arms that coil around the galaxy. These are the transition zones between the straight bar and the spirals, regions bustling with activity. We notice that gas and dust are particularly concentrated here. Great clouds have collected where the bar hands off to the arms, and within them, young stars ignite. Indeed, the ends of the bar are marked by vibrant stellar nurseries and clusters, lit by the glow of newborn hot stars. It is as though the energy channeled by the bar spills out at these junctions, giving birth to new suns that will populate the galaxy's arms. As we continue along the bar, we observe that it is not a uniform beam of light, but rather textured with clumps and lanes of interstellar dust. Dark ribbons of dust run along the leading edges of the bar, the same hidden rivers of material we encountered nearer the centre. They are still here, guiding gas inward toward the core. Under the gentle shove of the bar's rotating gravity, gas clouds slowly stream along these dust lanes like traffic on a cosmic highway. This inflow nourishes the galactic centre, ensuring that even as stars form and die, fresh material keeps arriving. In this way, the bar serves not only as a bridge of stars, but also as a conduit of gas, feeding the heart and linking the life cycle of the core to that of the wider disk. The stars of the bar themselves have a distinct character. Many are old, reddish suns, survivors from earlier epochs of the galaxy, now moving in orderly orbits along the bar's length. Interspersed among them are some blue-white newcomers, formed from gas that the bar has corralled. The mix of ages and colours creates a subtle mottling in the bar's glow, predominantly a warm golden hue from the older stars, with speckles of young brilliance where pockets of gas collapsed into star clusters. We pass one such cluster, twinkling near a dust lane, a tight gathering of massive stars, less than a few million years old, blazing intensely. They seem almost out of place amid the ancient stars, a youthful neighbourhood on an old thoroughfare. Drifting further out, we sense the bar beginning to thin. The stars are not quite as densely packed here as they were near the centre. The glow around us dims slightly, and we start to see more clearly the darkness of interstellar space beyond the bar's boundaries. Ahead, the full grandeur of the spiral arms reveals itself. These arms unwind from the ends of the bar, rich with star clusters and nebulae, extending far into the distance. We realize that the bar has guided us from the very core of the galaxy to the threshold of its vast disk. Like a bridge delivering travelers to open roads, the bar has led us to the entrance of the spiraling pathways that reach the outskirts. Looking back briefly, we can still see the bright central bulge we departed. It glows like a beacon at the center of the galaxy, and the bar we traveled is the shining causeway emanating from it. Looking forward, the vista is of great sweeping arms that curl away in layers of light and dark. It is a breathtaking perspective. Behind us, the concentrated light of the core. Beneath us, the structured lane of the bar. And ahead, the wide open expanse of the galactic disk. We find ourselves at a crossroads of the inner and outer galaxy, a perfect place to pause for a moment and gather our senses after the long journey through the center. In this spot, the brilliance of the galactic core is still near enough to bathe us in a gentle radiance, yet the darkness of the surrounding space begins to creep back in. We hover here, on the verge of the bright inner realm and the dimmer outer reaches, taking a rest in the inner glow. The tumult and density of the core are behind us, and the volume of space ahead grows broader and quieter. We allow ourselves a brief intermission, floating above the junction where the bar hands off to the arms, illuminated by the soft combined light of millions of stars. Here, the galaxy almost seems to catch its breath. and so do we. We linger in this calm, reflective in the golden light, before we continue our voyage outward. Observing this grand central bar, we marvel at the Milky Way's design. This galaxy is not a random swarm of stars, but an organized structure, a cosmic metropolis with avenues and intersections. The bar is like a main boulevard, directing the flow of matter and guiding the evolution of the galaxy's core. It demonstrates how gravity can sculpt order from chaos, arranging stars and gas into forms that endure for eons. In its steady rotation, the bar binds the inner galaxy together, and we appreciate the grace and purpose in its form. Leaving the brilliance of the inner galaxy behind, we journey outward into the broader expanse of the Milky Way. With each light year that passes, the gravitational grip of the central mass eases slightly, and the glow of the core recedes into the distance. The dense clusters and crowded skies of the center give way to a more open vista. Individual stars stand out against deeper darkness, no longer drowned in an all-encompassing radiance. It is as if we are wading from a luminous inner sea into a calmer, sparser ocean of stars. The transition is gentle and gradual. The galaxy does not end suddenly, but slowly thins and quiets as we move further from the heart. Turning to look back, we can still see the central bulge shining like a beacon behind us, a concentrated warm light at the galaxy's center. The long bar we travelled is visible as well, stretching out from that glow and then fanning into the spiral structure we now traverse. We realize how far we've come, from deep within that glowing hub, through its secret corridors, and out along the stellar bridge, and now into the wide domain of the spiral arms. The core's embrace is loosening. Its light now forms just one luminous region in the panorama of the entire galaxy. Out here in the wide disk, far from the hub, lies our own sun, a humble yellow star about 26,000 light-years from the center. Remembering that puts our journey in perspective. We have essentially travelled from the galaxy's very heart toward the distant realm where our home resides. Around us, the spiral arm unfolds in swaths of stars, gas, and dust. There is more space between star clusters here, more pockets of night where the cosmos peeks through. The pace of life is a touch slower in these parts. Star formation still happens in great nebulae scattered along the arm, but in between are vast interstellar gulfs, more tranquil than the bustling center. The contrast is soothing. We drift onward with a sense of calm, carried by the rotation of the galaxy into its outer reaches. Above and below, the sky grows darker, and the soft glow of the Milky Way's plane becomes a guiding ribbon through otherwise starry emptiness. We have eased out of the center's tight hold and into the wide open realm of the galactic disk. Here, under the faint silver of countless distant suns, we feel the balance of the journey, the pull of the core behind us and the beckoning void ahead. In this moment, suspended between the rich past we've explored and the vast unknown that lies before us, we are filled with both serenity and anticipation. The galaxy's central light lies behind us as a comforting memory, and before us stretches the immense starlit frontier of the outer Milky Way. Our voyage continues, ever outward, into the wide and open night. One day, perhaps, we will venture beyond the Milky Way entirely, out